I see that I've been going offline and online for 4 times or something, so that's a little bit too much. But I'm happy. Do I have some sound in the background? No. I put this one on. Not too loud. So I guess we are back now. Hi Mohammed, Musa, welcome. Awesome to have you back here. I hope things changed a little bit. What I meant with that is that the sound is a little bit better. I bought a new microphone, so I hope you guys can hear me a little bit clearer and with less noise. And yeah, give me a couple of seconds. I think this is working fine now. It looks good. I will get ready. Let me stretch them arms, legs. I don't know. Yeah. Let's have a drink. Make sure I have something to drink here. Yes, I have it. I hope the music isn't too loud. It looks like it's a little bit louder than my voice. No, not. No, my voice is louder. Nice. Loud and clear, buddy. Nice. That's very nice to hear. Very happy. Can I make this screen a little bit bigger? So I can read the chat. Okay. Okay. So let me click this, that, there, whatever. Okay. Very awesome. Let me just go right to the camera and hope that I'm sitting in front of it. Yes, we are. So hi everybody and welcome back to my live stream. And today I bought a Raspberry Pi. And what's a Raspberry Pi, you might ask? Well, you can see it in the screen. I have it up in the screen somewhere in the right. And that's my breadboard. Here's my hand. I have a webcam that is on front of it, on top of it. I'm sorry. And there is the Raspberry Pi that I bought. And I did install it, and that's what you see in the background. In the background, that's the operating system. I have it on my Windows PC, so let me minimize. How do you minimize? So let me minimize it. We are connected to the Raspberry Pi using, what is it called? Windows Remote Desk. And yeah, that's mainly it. That's mainly it. I have no idea what I can do with this. I bought a Super Starters kit. I don't know. Wow, that light is way too bright, but you can see it has a breadboard, the one that you can see in the screen, on top of the screen, and it has well, all sorts of stuff. I don't know. These are all sensors and things to do, but I don't know. It's all new for me. It's the first time that I'm using this. So what I did in preparation for today's live stream was that I pre-installed it a little bit. Well, it's not really pre-installed, but I recorded that today, that I installed it, I prepared it for today a little bit. I had to do some updates and stuff so we can communicate. And what we see in the screen right now here, if I understand this correctly, I'm not quite sure that I understand it correctly, but I think so. We see here in the middle, we see physical, all kinds of numbers, 1, 2, 3, 4, 5. I don't know if you can see my mouse. I think you can. Yes, you can. Okay, so what we see here are the pins that are there in the screen, if I am correct. We see the title here. We see 3.3 volt, and I can see with my finger here is 3.3 volt on the first pin. And then I see SDA1 here on the left side here. So I think that if we look at this list from top to bottom here, that will be with my finger from top to bottom there. And the right side of the screen, which is everything here in the screen, that will be this side of the breadboard. So I don't know. What we see now is, I think they are reading if there's any connection on it. So it's very new. Okay, let me get back to the chat. Mohammed Ami Musa said, "How is your health, my friend?" Well, I'm doing fine today. I'm well, not today, the entire week. I'm doing very okay. It's been a normal week, I guess. No health issues or something. No family health issues. So I feel very fine. Thanks for asking, man. I hope you're doing fine too. What else do we have? I'll be back. I'm gonna share your stream. You're gonna share my stream? Well, thank you, Mr. Brightside. That would be very awesome if you would share it. But I'm gonna try and figure out what this breadboard, what this Raspberry Pi actually is, because what we're seeing here is the Raspberry Pi. Is this operating system? It's a Linux operating system that's installed on it, and I'm just gonna try and get to know this. Well, you guys can see what I'm doing, I guess. I have some tutorials. I got it with my starter spec, so I think that's what I'm gonna do. I'm gonna show that in this screen. So I have, they gave me a PDF with all kinds of tricks, and as you see, this is all about the Raspberry operating system. And I think I should just work with the basics here. So I'm gonna keep this, maybe I should keep it somewhere here. Where can I keep that in my screen that you can see that too? Lesson 1, we're gonna make a blinker. Interesting. So, good luck for today. Okay. Yes, I'm gonna read this. In this lesson, we will learn how to program the Raspberry Pi to make a LED blink. You can play numerous tricks with an LED as you want. Now, get to start and you will enjoy the fun of do-it-yourself at once. Okay. In this experiment, connect a 220 ohm resistor to the anode, the long pin of the LED. Oh yeah, anode and cathode. Am I correct by saying it, calling it an anode and a cathode? So let me grab the stuff that we need and I'll put it in the screen. So they're talking about a resistor of 220 ohm. So that's the first thing that I have to do is get a resistor. So in this big box, you guys cannot see it. In this big box, there are all kinds of small parts. So here is a list. Let me show you here. It's come on. Let me make it a little bit easier for us. It's a paper and it says all the information of resistors. So I guess that I need to use this to get the 220 ohm resistor. So what would that be? There will be a red one. Am I correct? How does this work? We have modifiers on top of it. Let me show you guys. How do I keep it correctly? So this is a list that I got. It's not bright. Okay, so I need to learn how to read this stuff. That's where it starts, I guess. Get a 220 ohm resistor. Maybe I can find it on the internet. Is there any tip how to use this? And 220 ohm resistor. What would it look like? It says red, purple, and gold. First band, second band. Oh, so I think I understand now. So the first band. So we're talking about these lines that we see in the screen here. This red line is, what is it? In this case, a purple line, and two what is it called? Gold lines, I guess. And the third line is the multiplier. Okay, so that's important. This third line that we see here in the screen is supposed to be the what? How does this work, man? A 4-band code. This is all new for me. So give me a couple of seconds to figure this out. A 5-band code. We're talking about 4-band code. So I have multiple different resistors here. All kinds of different resistors, and they have all kinds of small signs on it. So all these lines are printed on these resistors. So I don't know. I'm not quite sure yet what it would look like, but I need to check them from up close. 5 bands. So are they different? These are definitely different. They have different lines on them. So what would be a 220 ohm resistor? 5 bands, multiplier. So it must be something with red, because it says on this line that the red is a 100 ohm multiplier. So I have no clue. I need to figure this out on the internet. I wish I had done this before. Here it says that it should look something like this. Do I have this one here? What is it? It is red, brown, gold. Man, electronics is very boring. Red, gold. I need 5 lines. So resistor 5 band. Color code for the 5 band. Yes. Okay. How do you read these color codes? Do you guys know this? And if you do, please let me know it in the chat. Cause I think it's gonna cost me a couple of minutes to figure this out, man. Why is this not in focus? 3 bands, 4 and 5 bands. 10.3 kilo ohms. Why is it 10.3 kilo ohms? One. First digit. So I need 220. So I need 2, 2, 0. Red, red, black. With no multiplier. Would that be the right thing to do? I have no clue. So confusing. Yes, I am confused too, man. I haven't done this before. What is this? The 100 kilo ohm. Did I need the kilo ohm or did I need the... No, not kilo ohm. It says the two. It says here connected 200 ohm resistor. Oh, it is drawn here. So why didn't I do that? Okay, so they do show it on this card, but I don't understand the card yet. But they do show me what it should look like here. It is... Wow, let me make close up. 2 black lines, a red line, and a brown line. I have a red brown line. One here. Man, it's so small, you guys. It's these things are really small. It's not that clear. Oh, here's green, definitely not this one. Black, black, no, because it was supposed to have 2 times a red. So it does look like this one. Well, it's black when it starts with. This one is with red. It's so confusing. I'm sorry, you guys. I think you guys think this is confusing too. Here I have red as well, but no gold line, because they start to give me the idea that here is a gold line. I don't know if you guys see that too, but I don't see gold on these things. Why didn't they write it on the papers? How would I know it? How would I recognize it? Okay, let me check the internet again. A, B, C, D. How does this work? A 200 ohm resistor color code. Red, red, brown, yellow. Red, red, brown. So I'm just gonna pick one. I'm gonna give up. We'll see what happens. So what I have here is one of the resistors that I chose. I hope you guys can see it. And it says here in the picture, let me zoom out a little bit, that I should connect it to GPIO 17 that we see here. So that will be... Well, I need to check out from top. GPIO 17. Why am I using the resistor like this? I have in this package, I have all kinds of connection lines. I got all kinds of connecting pins. So several pins. I'm gonna use that. I think that's a smarter way to do this. So let's do that. Let's do it like they show us here in the screen. It says put this somewhere. Oh, you're not seeing it? Give me a little bit more space. Something like that. And let's connect this to the board somewhere. Come on. Why are my fingers not working correct? So, can you guys see it? Oh, it's so thin. I think that is visible in the screen. So what are we doing now? We need an LED. Let's grab an LED. It's all in these packages. So a red LED, because if I remember correctly, it is also important to have the right color of light, because different colors of light need different voltages. That's a physical thing, physics thing. So we have two ends on a LED, or maybe I should put it here. We can see it, a small and a long end. Can you guys see? One of these connectors is longer than the other, and they call this an anode and a cathode, if I remember it correctly from chemistry. So what are they telling me to do? They say then the resistor to 3.3 volt and connect the cathode, the short pin of the LED, to B17 of the Raspberry Pi. Okay, so the short pin should hit the Raspberry Pi. So I put it in here. The long pin is connected to the resistor, and the short pin is not connected yet. So let me grab small wires, because we have lots of wires here. Do I have a scissors? Scissors. Come on, scissors. I'm gonna get a scissor. Got scissors. Woo, back. That was very quick. Yeah. Because here are all the connecting pins. I'm just gonna try what's gonna happen. Let me get two of these lines. And what was it saying again? We were supposed to connect the short pin to number 17 and the long pin to the resistor. Okay. So this would be the short pin I have here. So the way a board like this works, for if you guys don't know yet and you're sitting here thinking like, what the hell is going on? This board, well, everywhere horizontally, if you can see here, these 5 dots that we see here are already connected with each other. So whenever something is on the same line here on this board, and you see small numbers here, you see the number 20 here, 25, 30, those are the lines in the breadboard. So whenever something is horizontally on the same line, then it is connected. So I connect this one, the short one, to the number 17. I have to go up there. Connected to 17. I have connected one to number 17. And then I should connect this one to ground. It says here, ground. I should have it would have been smarter if I would have changed my setup a little bit. Maybe we're gonna do that later on. So now I think it is connected like it says on our screen here, the wiring diagram. So I did replicate what we see here now. And what's going on next? Okay, so if we would think of this as a chip, a black chip, just like well, I have chips here, just like we see, for instance, in this bag, these chips. So this would be usually how we would read those things. How we should read these things. Okay, so now test instructions. According to the circuit, when GPIO 17 of Raspberry Pi output high level, the LED is turned on. Conversely, when the GPIO 70 RPI is low level, then the LED is turned off. Therefore, we can let output high. Okay, we can cycle it and make the LED blink. We will use both C code and Python code to archive the target. Okay, C code 1 to blink. First type command to the terminal, observe the project result, and then analyze the code. Okay, so what are we going to do? We're going to use C++ this time. Or are we going to use Python? Let's use Python. Why? I don't know. Because I like Python. Today I wanted to work on Python. So today's video is all about Python. To make it blink, now let's use the Python language. 11 pi code, Python code. Let's try. Let's check out what's just gonna happen. So let's go into this. Oh, I should keep this somewhere safe. So I'm gonna put it on my other screen. So you guys, I'm sorry you guys can't see it anymore. We're gonna try this together. So it says, let's go and check out in which folder we are. The Python folder, cd11 Python code, blink. Yeah, let's just try and create a Python script. So how do you write new Python scripts? Python blink.py, no such file or directory. So I think we are just supposed to play with it. So I think we're gonna use a nano. So this would mean a nano is an editor, text editor, and if we save this now, then we created a new text file or a Python file in this case, because we created blink.py. So yeah. What up? What's up, bro? What do you guys think of this crazy price action? Wow, this crazy price action, man. I'm so confused, to be honest. I don't know. I think the price is high today, to be honest. But then again, it's low on the long term. So, man, we get confused every time. RPI.GPIO. Maybe I can copy paste this code that we have here. I will be very happy if that is possible. Would that work? It seems to be the case that it is working. I did copy paste. What just happened is I copy paste. Whoa, sorry, not like this. I will show you. I grabbed it from here and I copied it because I just want to see if it is working. Let me save this. Would this work? Set pins, output. I think this is a little bit weird that I see spaces here. I don't know. I thought this wasn't supposed to be like that. But yeah, let's just keep it the way it was. We can delete, of course, the comments. So let us do that. That's smarter. Just to be sure. So what was it? Control K to delete the entire line. So this would be a comment. Yeah. We can also do it like this. Just make it an ordinary comment. And this is part of the comment too, am I right? Yeah. So let's clean this up a little bit. Or the low level space. And now it actually looks like a real comment. So make it a comment. Yeah. Let's save this. Yes. To save it, press Ctrl X. And let's try and run it. Python blink.py. Okay. On line 15, but no encoding declared. Okay. So nano blink. On line 15. Where's line 15? Oh, it says pin and mode. Okay. So let me think. Let pin. It's a little bit boring, I think, for you guys, but you gotta bear with me. Use the command to enter blink directory. It says here that I need to have this folder. Where is that? Do I have that? CD, is it over here? No. Let's go back. Because I see here in this screen that I need to have a 11 Python code, but I don't think this is very important to have it like this. like we see here in our screen. I don't think we need that. I agree. You know it's cheap for the long term, but you don't want to go all in case it dumps back to 5K. Well, you might already know this, but it is a couple of days and then we have the halving. So let us check for fun, like I did last time in our live stream. Let's check this. It's, you know that when this number here hits the number 630,000 exactly, then the halving would occur. So it's only 346 blocks left. So let me quickly calculate that. 300 and what did I just say? 46 blocks every 10 minutes. And that should be so this is the amount of minutes that it would cost, that it would last until the mining or the halving is for the miners. And so in hours that will be 75 hours. In days that will be in 2.5 days. So in 2.5 days, yeah, 2 days. So what I think that it won't change. The demand will not change. I don't think demand will change after halving. I think it would stay the same. I think I know it's all about supply and demand, but the supply on the how do you call it, on the exchange websites won't change. You know, it won't change at all. So why won't it change? Because if there is, for instance, already 1 million Bitcoin on a website, if miners get only half more, then it means that the inflation on the website will be half. But the demand can change. The supply won't change that much. I won't expect miners to all of a sudden now want to sell less coins. They would sell the same amount of coins. Well, even maybe they would sell a little bit less, but not for a higher price. I don't know. I just have the feeling that because it's been pushed to us, that we get these pushes all the time, like Bitcoin is going to be so much more expensive, invest now in Bitcoin, and we get those. I don't know if you guys get that, but I get those push messages all the time. And whenever I get those messages, I started to think reverse psychology, let's call it like that. I reverse what they say to me. So whenever everybody's telling me you should buy, then I feel like I should sell. So what's happening with the price today? I thought it was going down a little bit, but I think that I don't think it's gonna last for way longer than it is lasting nowadays. But I don't know. I've made this error many times before, to speculate on prices. Well, one thing I know for sure is that I don't know for sure. That's the only thing I know for sure. That's what I can see. Okay, I wanted to work with this stupid Raspberry Pi. Well, stupid. It's the first time, and I have no idea how this works, or if I'm actually seeing something. Maybe I should check the GPIO again. So where is it? GPIO read all. Is there a difference now? So I did connect something to, which one was it? GPI 17. Can we see it here? GPI 3. Where would it be? Number 17. I don't see any case. Well, I'm buying slowly and hoping it doesn't dip too much. I believe in Bitcoin. Well, I think most of the viewers here that are here now at this moment, or that are here this upcoming week, most of my viewers on my channel would agree that we all believe in Bitcoin, but we cannot believe in Bitcoin on the short run. We all know that. There's a big difference between long-term thinking and short-term thinking. We have a very volatile market, which means whenever we're all getting scared at the same time, scared of fear of missing out, FOMO as they call it, or that we have the fear that we lose money, we're still in that time. There's too much volatility at the moment to really make strong conclusions. It can change any moment. And that's a scared thing, I think. But then again, you should just believe in it, just like we all do. Believe in Bitcoin. Okay, let me get back to that tutorial. Where is it? Yeah, the Super Starters Kit tutorial. Let me keep it somewhere here in our screen. Because what am I doing wrong? Let's go back up. GPIO 17. Should be connected to a 220 ohm resistor. How do I know if I have the right resistor? Can I check resistancy? Yes, I can. If I have one of those how do you call those? Voltage meters. So I think I have one in the back, because I don't know if I have connected it the right way. Maybe I should change my setup a little bit. So I'm gonna move this breadboard to myself. So. Hey, I'm double in screen. Okay, the breadboard, so I can see it a little bit better. So right now I have it right in front of me. So where do I put the camera? Something like this. Okay, so this one is in ground. This one is correctly in number 17. Okay, would this be the right pin? Let me check. So, yes, this is connected. This is connected. Why ain't I seeing something? It looks good. It looks good. I believe in this diagram. I think we have the same diagram. But why did I get this strange error? Maybe because I did something wrong. I didn't read everything like I should. Okay. I think I skipped some parts in this tutorial. So wiring, this is what I just did. I have this screen here. I'm quite sure that it works. GPIO read all, we did this. So what is this? GPIO 17, wiring pin 0 volt. It's number 13. Okay, header 13. So this one here, that's the pin that it's connected to. Okay, so I learned something new. It's small. It's small that with the things that we learn, but it's going slowly. Hope we figured it out. Okay, code operator. We need to transfer the code from the PC side of the Raspberry Pi operating platform A. Oh, sorry, the operating platform. A common file transfer platform is FileZilla. Yeah, okay, so we want the code on our Raspberry Pi, but we can communicate with the Raspberry Pi. So is this really necessary? I think that's the reason why I skipped this part. This software, oh, you guys cannot read what I'm reading. Sorry, it's over here. Let me, where's my control? Here, make it a little bit bigger. So we can read it together. So we need to transfer the code from the PC side of the Raspberry Pi operating platform. A common file transfer platform is FileZilla. I'm using Bitwise. You guys probably already know it, that I use Bitwise on my channel. I think it is almost the same program. I will show you guys. It's on Windows and it's called Bitwise SSH client. And not this computer. I need to connect to the Raspberry Pi, which is number, if I am correct, it was number 7, the Raspberry Pi, and the username would be Pi. And yes, now we are connected to the Raspberry Pi as well, using Windows. So this would be, as you can see, Pi at Raspberry Pi, and here is Pi at Raspberry Pi as well. Also, at the background, we see the operating system that is installed on the SD card on the Raspberry Pi, and this would be just our file transferring system between our Windows background, the one that we see here. For instance, you see here Fartcon server backup, and here we have backup. So this would be my desktop on our Windows PC, and this would be the desktop, well, not desktop. If I double click on desktop, this would be the desktop on our Raspberry Pi. So I expect, if I copy the stream list, this is the list of words that you see down in the live stream. Now I would expect it to be on our Raspberry Pi as well. So remote, and as we would see here on the background, we have a streamlist.txt. If we would open it, we would see this is what we see down in the screen. So okay, we know for sure that it is working, that we can communicate between Windows and between a Raspberry Pi. But what are they saying in our tutorial? I'm not using FileZilla. That's what I'm trying to say here. Connect to it, use port number 22. Yes, that's what we did. That's why I have here, well, come on, here, port number 22. This is the IP address. If you want to check the IP address, you probably, let me get my keyboard. Oh, I have no place for my keyboard. You would write ifconfig, and you will be able to read your IP address somewhere here. So this would be the IP address. You guys can see it. It's number 7 in this case. So if I would go back to bitwise, I'll tap, where is it, bitwise? Oh, here. We will see that we are using number 7, and username would be the same that we see over here, and the password would be your password, obviously. So never show passwords. Okay, so we are quite sure that we can communicate, so that is not the problem that we're having at this moment. Let me move my keyboard. Okay, let's go back to the tutorial. Where are you? Here. Okay, so you should be able to connect. After downloading and installing, open the software, yeah, let's connect to it. After connection is successful, select the code folder. So they want us to upload our own code folder provided in the information provided by the learning kit. Okay. And where do they want us to do that? To the home Pi folder. Well, let's just copy that stuff out. It's a little bit boring, this, am I right? So let's do this on my Windows. Let's create a new folder. Why can't I do it now? Create a new folder. Let's call it the Raspberry Python. Open it, and they were talking about a special kind of folder called left-fin Pi code. So let's just try and copy everything that they say, because I think we're doing something wrong. LAFVIN underscore Pi underscore code. Like that. Is this correct? Yes. Okay. And you want it in the home Pi folder. Okay, let's do that. Let's upload it. Refresh it. Now I have this folder here, so we can see it here. I think as well too. Home Pi. Yes. Now we have this folder in our Raspberry Python. Okay. So let me go back to the tutorial. We created this folder, saved on Raspberry Pi on the right. Okay. We would see that it has been copied to home Python. Right click, mouse, and press upload. Yeah. It's a little bit basic, but yeah. After successful upload, you will see the path of the code transferred from PC side. Yeah, is home Pi 11 code. Yes. We see that here too. Okay. This path is very important. Then our This path is very important. Then our program operation is directly from the home Pi left-fin Pi code path. If this path error will affect, the subsequent course learning. Okay, whatever. Yeah. So what do they want us to do now? So within this code, Python, we should have 2 folders, C code, Python code, I think. Okay, let's just try and do that too. So here, we need a new folder. And what was it again? What did I just say? C underscore code. C underscore code. And a new folder. Python underscore code. I didn't know I have to do all this. Okay. Let's go back. This is all preparation, man. Python code. Yeah. After successfully connecting the remote desktop and transferring the code to Raspberry Pi platform via File 0 software, you can edit the code in a program editor that comes with the remote desktop. Okay. I'm a little bit confused. So, okay. Genie program editor. So I have that here. Programming Genie. Okay. I have no idea what's going to happen. Oh, this is that same program that we just opened. Okay. So not stream list. Let's make a new file. And let's... well, we already have a file. We just created it. So let me copy it to the Python code. So here. Does this work? Yes. A new file. It was on... here, blink.py, copy it over there. So would what would happen now? How would I run a code? How would this work? Okay. 11 code, C code. So if I would double click this now, what would happen? Now we're zoom, quit, load. Okay. Here's the Python shell. Oh yeah. Line 1 in module. RPI is not defined. Hey, it's all new. Oh, so weird, man. I thought this would be a little bit easier, but then again, it's always the same when you start with projects. So, okay. After successfully boring, yeah. 11 open file Genie. Okay. Let us try that. Let's close this file, close this, and say here file, open a file, and let's search for that Blinky file that we just created. Code, Python code, Blink. Okay. So now we have a code in, I think, Genie. It says in the tutorial that we're supposed to do this. I'm just gonna do what they say here because it's all new. All new. LED button in C. LED button, Blinky. Import LED pin. Ah. Okay. So I think here are some things that I should do. Set the mode for pin serial number. Here, so I think we need to edit this. I think we need to edit the pin and this mode here again. It's so weird. I wish there was somebody who could help me. Okay, but how will we run this? Here we have it again. So this would be a C++, this would be a Python project. Ah. So it looks a little bit different if I check here in this Python screen. We see here. Where's the zoom? It's a little bit different than how I am doing it here. So let's just try and change it a little bit. Like, come on, why can't I have it on top? So I have to put this in another screen. Sorry, you guys can't read with me together. Oh no! Oh, okay, I accidentally removed that screen again. So I should be here with my mouse. Okay, line 1. We should open by telling where Python is. That will be on user, the bin folder, and then the environment, and then we should run Python free. That will be line 1. And then we need to import what are we importing? The RPG GPIO. Okay, we're gonna import it as GPIO. I don't know, it says in the tutorial that I should do that, and it want me to import time. Okay, not with capitals, so import come on, import time space, set the mode, I don't know. I'm gonna delete this. So let's do something differently. So we have import of the time, GPIO. We need the LED pin. So LED pin equals 11. So that will, and then we need to define the definition, and then we call this setup. And was it double dot? I don't know. GPIO dot set mode, GPIO dot board. It's so new for me. It's a little bit tense, this. GPIO dot and then setup let pin comma space GPIO out, GPIO dot out. Python, man, weird language. Okay, so now we're at GPIO dot output, oh, not space, and then let pin again comma GPIO low, GPIO dot low. Oh, I should have capital letters, low, and then we want, okay, print, we're gonna print the used pin. Okay, used pin like that, used pin, and then variable let pin. Alright. So it took me a while. What I did was I simply just copied everything that we saw here in this tutorial screen. And okay. And now, what am I supposed to do now? How can I run a code? What am I doing now? I'm reading this. So let me show you what I'm reading. Python code. So let's go back. I start. Oh, stupid mouse. I started here with this little part. I copied it, but there's no more information. It just shows me some screenshots of this program, and I don't know yet how I run a code. So I wish it was easier, man. I wish it was way easier, but it's kind of hard, to be honest. It's hard because I don't know what I'm doing, and it's always hard when you're doing something for the first time. To turn on a LED, we need to make below 0 level. It can be realized by programming. Okay. So I hope I have the right resistor. That's the only thing that I'm not sure about, this resistor that I have here in our screen. Here, this one. I'm not sure of if I am using the right one. Okay. First, use the command to enter the blink directory. Use Python command to execute Python code blink. Okay. Oh, we can try that. So, let's go to that folder that we just created. So that would be ls for listing. What was it called again? Oh yeah, the left fin. So we cd la tab, and then it was Python code. So now I would see the blink.py file. Oh, you guys cannot see it because it's behind my back, but you see here blink.py. So Python blink.py. I still have an error. Why? Have I saved it here? I don't know. Now I have saved it. I didn't save it yet, so retry. Is there something happening here? I don't see anything happening. I don't see a blinking light. Why is it harder than I thought? Python blink.py. Okay. It's not even printing this. So I should run this definition setup, define setup. Well, it should run by itself. Am I correct? Why is Python so new for me? And I did work with Python before, so maybe I can find some information in my older projects. It should automatically start it. Well, how do I run something? How do I run a diff? So how would I run this setup file? How did you do that? Wasn't it saying something like setup like this? Or is that in C++? Sometimes it's so hard programming, especially when it's when you don't have a normal teacher. So I think this would be the trick. Let's try. Unused format character D at the index 9. I did copy this part, so what we're saying here is that I did something wrong here. There is an error here, but what did it do wrong? So I think this did work. The fact that we run the defined setup here. So this line is okay, but giving me an error for this line. So let me make it a comment quick, save it, and check what happens now. Okay. This channel is already in use. Continuing anyway. Use GPIO set warnings false to disable warnings. Okay, GPIO setup let pin GPIO out. Okay. New. So something goes wrong here. GPIO out, low, GPIO board. Let's go back to the tutorial. Oh, wrong. Okay. This is a Python module controller in the Raspberry. It includes basic output functions and input functions of GPIO and function used to generate pulse width modulator. Set the mode for pin serial number. GPIO. So, how would you use that? So let me go back and check another code. What kind of code explanation would this be? First observe the project result, then okay. Maybe I'm doing something wrong. Maybe I'm supposed to have these programs already on my computer, because I got a DVD where I am running this file from. So maybe I'm doing something very stupid. Maybe they gave me already some scripts. So let me check. You guys see what is happening? I apparently already have these codes. So what I've been doing was a little bit stupid. I was making things myself, something that I didn't have to do. Because I think if I look here, yeah, I have blink here, and here is the blink.py. And what is in? Oh, don't run the script. Open it. Okay, so the script wasn't correct. As you can see, it was supposed to look like this. So I was doing something wrong. The tutorial wasn't teaching me how to write it. The tutorial was explaining what we were supposed to see, even though I didn't understand it correctly. Oh, here they use FileZilla, PuTTY. Ah, okay. I'm starting to understand what they want me to do. They want me to copy this to my Raspberry Pi, to that thing over there. Okay, let's do that. Okay, now I'm starting to understand. Oh man, I wish I knew this before. So this is the folder that I'm supposed to go to. And how do I get different volumes? Where do you do that? What was it? It was drive H. So I need to go to H // not // H // and I need here. This one can be deleted apparently, and let's copy paste everything to the Python folder. Nice. And let's go to the C++ folder. Man, I wish I knew this. Upload this. Okay. So let us rethink everything that we just did, because we tried to do something ourselves. Here it says, do you want to resave the file? No, cancel. Don't do this. Don't save a file, open the recent file, and I expect it to look different now. Okay, it's not looking different. Why? Because it was moved to a different location. File, open. Oh, it was the right folder. Home, Python code, the blink code. Now it started to look different. Awesome. So this would be the code that would be able to execute a blinking thing over there. Let us try that. I'm very curious. So listing. Now we see here that we updated that folder, because when we listed it before it was different. It was only showing us that, what was it, the blink.py file. So now we have to enter cd folder 1 tab. Why isn't it working? Oh, just 1 underscore tab blink list, and we see blink.py. So now Python blink. Why isn't it working? Oh, it's supposed to be with a capital B. Okay, nothing is happening yet. Okay, but we're not getting an error message. Okay. Okay, so what's going on here? Runtime warning. This channel is already in use. Continue anyway. This channel is in use. I don't know what that means. Let's grab the tutorial again and let's have the original code here in the left of our screen. Something like this. So this would be the right code apparently, but I think we need some changes. So let's go back. Because we were working with tutorial number 1. Okay. The code explanation. Let me zoom out a little bit. Can we read this? Yes. Okay. So the RPIO, GPIO here, the first line is import. This is a Python module to control. Okay. Then we want to import time. I think we need the import time because there is a time function later on, which is a looping function. I think we're gonna see that here. Oh yeah, here, definition loop. While true, out, let pin. So pin 11, board pin 11. Okay. What would be 11? So I thought we were using pin 17. Physical number 11. So that's this one. 1, 2, 3, 4. It's the 6th one from above. 1, 2, 3, 4, 5, 6. I am in the 6th one from above. So what am I doing wrong? How would I even know if there's something connected? How would I see that? I don't know. Set lab pins mode is output. Where was it? Set lab pin low. Lab pin is 11. RPI board pin 11. Board pin 11. Where do I see 11? The 6th one from the top. So how would I know if it would actually give me a signal? How would you see that? Do you guys know that? How I can check one of these ports? Because I have no clue at all. It's very hard. So show me, read it again. Mode in, out. Let's connect to ground here. So the small part is connected to number 17. That's what they said here. I just wanted to blink, come on. So 1 is connected. The short part. Okay, let's check, let's be sure. And then the resistor connected to the cathode. The short pin. Are you saying me that I did it the wrong way around? Because a LED can only allow electricity one way, from left to right and not from right to left, or from plus to minus, minus to plus. So would that be the error that I made? I had it upside down. Oh. I'm such an idiot. Okay, so now we have a blinking LED. Wow, we finally have something working. It only took me an hour. It only took me an hour to have a disco light. Yay! Yes, we're using Python, and it is actually working. Wow, I'm happy. I'm happy, you guys. I don't know if you guys are happy to see some results, but we have a result. We have a disco light. Wow. Oh, yes, it is working. I'm very happy that it is working. Okay. Let us examine the code now that we are sure that it is working. So let me put this code over here. So what are we actually seeing here? So it says here we're using LED pin number LED pin. We're calling it LED pin. This is a variable that apparently is created by the tutorial creators. You can change this name in whatever you want, but we have it here again and again. So wherever you see the word LED pin, it actually says 11. So we can put 11 here by hand as well. Set LED pins mode is output. Okay. Oh. So we're saying that the pin is an output, and then we're saying that the pin is low to off LED. LED pin low to off. So we're putting it off. Okay, so that's what this said. Number of GPOs by physical location. Set mode GPO board. Number of GPOs by physical location. I don't know what this means. This is new. It's all new, apparently. Okay, so this would be the setup, apparently. Just to tell which one of these connections we are using, and the yellow line that you see here is connected to ground. So let me grab that visibly. Whoa, I'm going way too fast. So here we would see that it is the 6th from the bottom. So 1, 2, 3, 4, 5, 6. So it would be this one. And as you see, there is no voltage on it. Voltage is zero voltage. So this was the ground. So it's connected to the ground and connected to a it's GPO 17. So to this line here. Okay, cool. And in the code, we're talking about LED pin 11. So that's this. If we would do 13, it would be the second one, I guess. 12 will be on the other side here. Wow. Define destroy. Okay. Keyboard interruption. When Ctrl+C is pressed, the child program destroy will be executed, and when we destroy it, that means exit it. GB output LED low, LED turns off, and we're cleaning up, release the resource. And then to run the program, if name is main, which means that if this file that we are watching now is the only file, the main file, then start the program, then run setup first, and then try to run this loop. Okay, and when it is looping, it says LED on, and then wait 1 second and turn it off. So that's how this works. Okay, so turn it off. Awesome. Wow, I'm very happy that we got something working now. Okay, I saw some more tutorials. So let's go back to the tutorial folder and see what else they have in here. So this was the blinker, the setup. So number 17 to ground. Ground would be yellow. This little thing that we see over here would be the resistor. Am I right? Yeah. Resistor is connected to ground. I have it different. I have it the other way around. I don't know. It looks differently than that I have here. So it says ground to the short one and then make this jump. Okay, I don't think it matters. It still works. maybe you guys, I don't know if any of you is into electronics, but if you are, then please help me out and explain some things to me that I didn't know before. Okay, the button control LED. Okay, let's try this out. In this lesson we will learn how to turn a LED on or off with the on or off button. Okay, we have buttons, so let me grab a button. Get out of here. I have a button over here. A small button, as you see. Buttons are common components used to control electronic devices. They are usually used as switches to connect or disconnect circuits. Although buttons come in a variety of sizes and shapes, the one used here is a 6mm melee button, as shown in the following pictures. Pin 1 is connected to pin 2 and pin 3 is connected to pin 4. So you just need to connect either pin 1 and 2 to pin 3 and 4. Okay. So how would I know which one is pin 1 and which one is pin 2? Okay, so I hold it like this. And then we're talking about this side to that side. So it has small claws. So from the side it would look like this. Can you guys see it? Oh, it's not clear. But yeah. So I should put it somewhere like this. Let's put it just anywhere on this breadboard. Come on. Work with me, breadboard. Or should I put it on 4? Let's jump of 4. Yeah, I'm talking about 4 pins. So what is, I don't know. I have a button here now. Okay. This would be the button. So 1 and 2 are connected. So yeah, 2 pins here are connected to the pins from that direction. Okay. When the button is pressed, 4 pins are connected, thus closing the entire circuit. Okay. When a button is pressed, 4 pins are connected, blah blah blah. We use a normally open button as the input of Raspberry Pi. The detailed connection is shown on the schematic diagram below. When the button is pressed, the B18 will turn into low level. Okay. We can detect the state of B18 through programming. So detect the state of B18 through programming. That is, if the B18 turns into low level, it means the button is pressed. You can run the corresponding code when the button is pressed, and then the LED will light up. Note, the longer pin of the LED is the anode and the shorter one is the cathode. Anode, cathode. Okay, so here we have that same setup again that we just had, that we previously had. That's this part, this this right part. So let me check and be sure, because I have a small error here in my work here on my board, because apparently I need to have port 17, as we see here in our screen, connected to the resistor. So this one, this orange line should be connected to the resistor first. So let's do that first. To the resistor. So come on. So now we have the resistor first, and then the resistor should be connected to the LED like this, I guess. Come on, like that. And then ground should be back. Put ground back on, and let's retry if it would work. Let's go back to here. Oh, get back here. Will it still blink? Yes, it is still blinking, so that means that it is still working. Okay, awesome. Turn off the blinker. Okay, the blinking is working. Let us open that other, the second one, the button LED. Okay, so the LED, it's almost the same script. See, small difference, not much. What's the difference? We're not using a time-based thing here. We're using the button pin here. Okay, so that's the main difference. Okay. Let's go back to our schematics. So schematics here. Okay. So the switch should be connected to the ground. This yellow line here is the ground. So we can do that first. So let's grab yellow again to indicate ground for us. So let's put them together. They can be in the same line, the ground line. And let's put ground on one side of the button, this line. So one side of the button has ground. So we connected this green line here now to the button. And now we need two resistors, a 10 kilo ohm and another 10 kilo ohm. So I don't know which one is 10 kilo ohms. So here we go again. We need to figure out the 10 kilo ohm resistor. Why did they give me a list of the resistors that they gave me? Because we have been doing this before. So it is again this very how do you call this, hard to understand list. 10 kilo ohm. It has yellow says kilo ohm here, so I need to have a yellow line, a yellow multiplier, which is the multiplier is the fourth line, should be yellow, so that's an indication on the resistors that I need. And I only see one with yellow. This is the only one having a yellow line, and it has the yellow line on the right corresponding location. So you cannot see it, it's too bad. But I'm quite sure that I have to use these ones, because there's only one sort of resistor with the yellow line in it. So I'm grabbing two of those. Let's put them here already in the screen, and let's check the schematic. So we want it to be connected to GPIO 18. Okay, and we need one connected to the 3V. Okay. Oh yeah, and we already see here that the button pin is number 12. We can see that here on top on our screen, and we know that it is numbered. If we check the chip here, 1, 2, 3, 4, you see, from left to right. So these are the uneven numbers, these are the even numbers. So here we see 17 with my finger, and here we have number 18 on the other side of the chip. So we can start with that. So let's grab a small line. Let's choose a resistor color. Let's choose these ones, a blue one, blue line. Why blue? Blue for resistor lines. Okay, and it says apparently that we need to put one. Let me move the breadboard a little bit in the first one, so that make sure that I do it correctly from the top here in the 3V, and we need one in the number 18 port, which is over here. Come on, correct one, that one. Okay, now we have two lines. We're talking about this line that we see here in our screen. Let me show you here. This line, stop line, the 3V line, is the one that I'm holding at the moment. Well, this one is here on the top, and it's supposed to be connected to a resistor, and then we need the other one connected to the same location. You see, these two are here together again. So let's start by doing that. Okay, we need the two resistors. Move this a little bit over there. Let's give ourselves some space, a new working location. So let's make a resistor on this side. You are going to be connected with a resistor. So here, come on, just somewhere, doesn't matter. So I'm connecting that one with a resistor, and let's connect another one with a resistor. So let's do it on the other side. This line is supposed to be here. It's smarter. Come on, work with me. And wait a minute, the resistors are supposed to be connected together. So but where? We see that this line here is the same one that we see over here. So this point where, I don't know if you guys see my mouse here, this connection here is where my finger is now. It's on this side of this resistor. So they should be connected together there. So the resistor on the left, this one and that one, they both should be connected together. And now I should connect this one, this line with this connector, this blue line, resistor, I'm sorry, this blue line with this resistor over there. And now what did we create? We're not yet there, we forgot something. In this diagram, we need to connect these two here with the other side of the button, and then we are complete. So can we do that by hand? Well, we can even do that simply by moving this. Okay, let's do that. Connect it to the button. So now I'm quite sure that the schematic is working. I hope you guys can see it. Can you guys see it? Make it a little bit bigger. I think my camera isn't that clear. That's too bad. I don't like it, but it seems to be complete now. And let us try and run the let button code. So let's go back here. Let's go back one directory, // and let's go to the number 2 button LED. Now we are in the folder button LED. List it to make sure. Yes, button LED. So let's run Python and then button LED.py. Why is it saying this? It's not working yet. Okay, something is going wrong. What's going on? Button LED.py. What's going wrong? You guys know what's going on here. It has a loop and we're seeing LED off and it's looping the entire time here. So there's going something wrong here. Can we check read all? Do we see something here? Connected to 18, yes. 18 to the resistor, resistor to the button. Yeah. The other side of the button, let's grab the schematics again. Windows. Need to be in Windows to do that. Where's the schematics? Because it seems like I made a small error. So one side of the button is connected to the ground. The same ground that is connected to the LED. Yeah, that's this yellow is all ground. Okay. And then it is connected to the 2 resistors. Yes, the resistor is connected to, one is connected to port, which one is it? GPO 118, this one, number 18, and the other one is to 3. Huh? So why you no work? Why I have error? What's going on? Keep getting this error. Damn it! Lost except hook is missing. Destroy, release resources. What's going on? GPO in 1. Bool put up, GPO PUD up. I don't know. Let me make this a little bit smaller. Okay. I have the feeling that maybe I did something wrong. Maybe I had the light wrong again. Nothing is working. It's so hard, man. It's a lot harder than I thought. Let me retry this. CD, and then let's go back to the LED. 1 tab, 1 underscore blink, and run Python with blink. Yeah, it's still working. So why isn't it working at the moment? That other script. Maybe I'm using the wrong resistors. Maybe that's the thing. Could that be the case? Could it be true? Could I be using the wrong resistors? I don't know. LED on, LED off, clean up. I don't know. Wow. It is the right one. Number 17. It should work. Why not working? You have this one in the wrong. Oh, it's also in the right pin. So let's retry it. Button LED. Still get an error. Okay, let's move on to the next tutorial. Disappointing. Let's try another one. Flowing LED lights. Oh, this looks like a lot of work. Wow. So did I have, maybe I did an error here. It says 10 kilo ohms. And I'm so sure that this is the 10 kilo ohm. There are no others. No, it must be this one. Yeah, 100. Yeah. Confusing. I'm sorry that it's not working at this moment, but yeah, let's just read some more just for fun. I want to know what else is here. So we have an LED flowing wiring diagram, different resistors. Wow. GPIO 4 70 22. Okay, I'm gonna build this. It's too much work. RGB LED. Okay, what's RGB LED? Has an integrated 3 LEDs. Okay, so I must have an RGB LED somewhere in this package that I have here. You guys can see what I'm checking out, because let me show you. Yeah, it's a little bit messy. Come on, cable, work with me. Show me. So I have a box with all kinds of parts that I got with it. And I don't even know what it all is. It's all new for me. You can't see it that well, I'm sorry. Searching for this one LED that they're talking about. Nope. Would it be this one? No, this looks like a infrared receiver. So it's not that one. Okay. I don't know. It says that it's supposed to have an LED RGB set, so maybe it's in here. I see lots of colors. I see some transistors, but I don't see an all-color LED. Okay. Nope. Where are you? Maybe it's in here. Ah, here it is. I found it. I found it. There it is. This one. I don't know if you guys can see it, but it has 4 pins. Okay, so 4 pins. Let's try and work with that. Maybe that's fun. So let me put this camera back here, somewhere on top of the breadboard. And let me reset the breadboard. So let's just do that. reset everything. And how do you reset it? Just remove all the parts. One LED here. These are the resistors that we used. Remove this button. Still bothered that it didn't work, the last part. Okay. RGB LED has an integrated 3 LEDs, yes, that can be respectively emit red, green and blue light, and it has 4 pins. The long pin is the common port, that is 3 LEDs positive or negative port. The RGB LED with common positive ports and the symbols are shown below. Okay. Okay, so the long one, and let me show you, let me put them over here. So this, it's the second one from the right for you guys. That one is apparently this one, the in. Electricity has to come from the first pin, so that would be this pin. I'm gonna bend it a little bit. So that's the first pin, and then we put number 2 and 3, something like this. So now we have it. So 1. Let me think. This is the second one. The third one should be. Just give me a moment, you guys. Third one. Because what I'm trying to figure out is how to remember which one is which. Or maybe I should put it so from the top to the bottom. I'm gonna put it somewhere here. 1 line, 2 lines, 3 lines, 4 lines. Come on. It's pretty hard, man. I don't want to destroy the stuff, so I'm trying to be careful and give it a little bit of force at the same time. So what I did now was I connected them to grab a screwdriver. Makes it easier to show you. I have one here in this hole, there 4 holes from the top line from here. So these 4 are connected. That's where the LED is at this moment. Okay, so the 3 primary colors of the RGB LED can be mixed into various colors by brightness. The brightness of LED can be adjusted with pulse width modulation. So pulse width modulation would be, yeah, how would you call that? It's a square wave sound. Yeah, that makes no sense if you're not an audio producer, but we'll get into that. Let me just continue. The soft pulse width modulator library simulates pulse width modulating by programming. You only need to include the header file soft pulse width modulator header for C+ languages, and then call the API it provides. Okay, let us check. Here is the diagram. So it says put resistors on each of the lights. Let us do that first. So let us recreate what we see here. Okay, look at this one. The first one, this line that we see over here, the most right one here is the green line that we see running here. Okay, green one. So let me grab, just to make it easier, a green line and put it on this one. So green is connected. And where is green going? It's going to port 3V3. That will be this port over here. 3V3. So maybe it makes more sense if I turn this a little bit around. Turn the camera around like that. Sorry, but now the schematic makes a little bit more sense when you're watching this when you're watching this live. Now it makes a little bit more sense. So I have the LED here. It's not that clear in shot. This is the LED. This is the first line, and I'm going to connect. Well, let's do the second one, a purple line, and let's simply grab. Well, I'm gonna grab a red color in this case, and we need an orange one, and we need a blue line. Let us just copy what they say here in the tutorial. So the blue line, and let us grab the resistors that we need. Okay, so which one is it? I have one here. It did work before, so we need this one again. Which one is it? It is purple, red, black, black, brown. Okay. Where could it be? Give me a sec, you guys. I got so many different resistors to check. Is it this one? Let me compare. Nope, it is not the same. Man, this is so hard. Here we have it. I found them. Okay. These are the same. Let's grab me 2 more of those. Now we are complete. Oh, you didn't see what I did. Oh, I'm sorry. So let us do this first. It says in the schematic here that it's the same resistors. So begin with that. Put in the resistors here. 1 resistor. Come on. To the other side. I'm bending them terrible. Wow. They don't look good. I know it's a little bit boring today, this live stream, but yeah, I gotta figure this out, man. And I didn't know if this would be interesting for you guys. I thought maybe you do like it, maybe you won't like it, but let me just try it. Okay. And the 3rd line for the last LED. Why is it so hard to pin these things? So, okay. So this first line, which one is it? Let us see. Connected to which port? 17 again. Okay, let's do that. Let's grab 17. That's this port. Oh, come on. 17 and connect it to one of the resistors. But which one of the resistors? The most left one? Doesn't matter. Let's choose the most left one. That's the 3rd one here. Can you guys see what I'm doing? It's such a how do you call it? Mierenneukerij. That would be the Dutch word, but it's very small work. You need to be very close to see what you're actually doing. And this one over here. And the last one would be the blue one, connected to 27 to the final pin. Where would be the final pin? The 4th pin would be this one. And connected to number, which one? 27, did I say? Yeah. Dare I say it? Here is 27. Come on, give me some space. This should be the right diagram now. Okay. Here. Green is connected to 18. Okay. What did I do? 70, 27. Oh, here on this diagram it looks different. Here they say free fault free, but this is also free fault. So I guess that would work too. So let us try and execute the code. Let us check the code and read the explanation later. So put this a little bit, oh, not like that. So here we were doing number 3. Am I correct? Let me make sure that I'm doing the right thing. Come on. I'm a little bit messy at the moment. That one. And was it 4 RGB LED? Okay. So CD double dot. show me the list. It was number 4, so CD4 tab RGB LED list RGB LED pi. So Python space RGB LED.py. We're not seeing anything. Why is nothing happening? Did I grab the wrong resistors? What's going on? It's so hard, man. Is the schematic wrong? How do you check this? 3-volt on the inline. Yes. And then these are all different grounds. I need to check closer. Second one is connected to the 3-volt. Maybe I should put it on another pin. Maybe on pin 1. So what I just did was I rerouted this green one. Maybe that works. Nope. It's so hard. Trying to have fun here, but it's not fun anymore. Okay. Resistor is number 18. Is it connected the right way? Yes, it is. Why am I doing something wrong? I get no reaction. There is no light. Why not? They are connected. How can I see if it's working correctly? Come on. I have no clue. How will we see what we're doing actually? Let's go back to Windows. Here. Because I'm running the code and it's not working at the moment. So let us run the code again. Oh, let us check the code. So I was running this one, RGB LED. Pin 11, 12 and 13. Yes, that's the ones that we're using here. Because this red one is connected to 11. This one, red. The green one, in this case, is this orange line that we see here, connected to 12. And this is pin 13. So, why no working? Program is starting. It's doing something special. Getting random. Yeah, making some lights. But why isn't it actually working? The pulse width modulator set frequency to 12K. Hey, pulse width modulating, it's all new for me, man. So the program is starting, but nothing is actually happening. That's not cool. I thought maybe connections were not connected the right way, but nope. The only thing I can think of that might be wrong could be the resistors or the way I connected the LED. Let me recheck. So the LED, the second pin, which one is the longest pin? Should be connected to what? Here, let's go back up. Grab this thing again. So number 1 should be connected to this green line. 3-volt. Okay, And the other ones should work, so why isn't it working? Retry. 1, 2, 3 pins. Okay, I have to remove this again because it's too far away from me. Come closer. So you guys can see it a little bit better. Okay, so apparently I'm doing something wrong, but what? How am I supposed to know what I'm doing wrong? Teacher, where are you? Where's my teacher? There's no teacher. Oh, why not? Because you haven't hired one. Come on. I don't want to bend these lines. What am I reading wrong? I'm doing exactly what they say. I keep this one here. Connected to the number 3 volt connector. Why not working? Okay, I'm having a hard time right now, you guys. This is the second one that I don't know why it's not working. So I'm expecting myself to do something very wrong here. Should be 18. Connected the right way. Number 7, 27, 3 volts. Why isn't it working? Stop being so mean to me. I'm not seeing anything. There is something going on, as you see here. The red light is working. So if I would put a green light close to it, no. So slide over here. So a red one. How did I connect it? What was it again? The long part to the plus. Oh, yeah. Long part to the plus, short part to the minus. And then we have a blue light as well. Long part to the plus, and then the short part to the minus. Now we do have a random working RGB light. So if we check here, it gives us at this moment the exact RGB random power, I guess. I'm expecting 100 to be 100% of the light and 0 to be off, and it's just randomly showing us some combinations. It's just switching. Are you using a tutorial? Yes, I am using a tutorial, Mr. Jack Hillard. Yes, it might be interesting for you, because what I did was I bought this Raspberry Pi. I'll put it down here. My super starter kit for the Raspberry Pi, so you can see it. And what they gave me was a small set. So this is a tutorial DVD book that I got with this set that I bought, and that's why I'm just playing around and trying to figure out how this actually works. So if you are new to this, I don't know if you are new, but what we're seeing here at this moment, this background here, is the Raspberry Pi operating system. It is a Linux, just like the Debian Linux. I think it's called Raspbian, just like Debian. And what it does, well, it is this computer that you see over here. You saw me move the camera here. So this is the PC. You have an SD card down there. Well, I don't know if you can see it, but there is an SD inserted, and that runs this operating system. And we are able to communicate to this breadboard using, well, what we see here, this big cable that comes from the Raspberry Pi. And we can use Python to run scripts. And I got with this set, what I got was a couple of already programmed scripts. So this is a already working script. And the script that is running at the moment is the one that I'm showing in the screen right now. And what it does is it randomly generates a number between 0 and 100, which would mean the percentage of brightness that we see here, where I'm pointing with my finger, for each of the LEDs. And yeah, there are each of the LEDs is connected to this extension board here. So I don't have the right colors for cables, but these are the ground cables for the LEDs. And officially I was trying to use this light here. This was an LED, an RGB LED as they call it. It has 4 connectors, as you see. And it is supposed to be connected the way that I have connected these 3 here, and it's supposed to work, but it's not working. So I'm doing something wrong, but I don't know what. What I do know is that I'm also doing something right at the moment, because these LEDs here are just randomly, randomly flickering. Is that this? They are pulsing. That's the word. They were pulsating randomly. So what I'm trying to do is just understand how we can actually do something with this. And the only way to do that is by doing already existing tutorials. So yes, I am using a tutorial. One that I got. So what are we actually seeing here? So let me stop this. So stop it. Control C to stop it. It's yeah, when Control C is pressed, then we keyboard interrupted, we destroy it, then all the lights are stopping. Okay. Pin 11, 12, 13. Those were here. And this green light here, this cable here, can be moved also to pin number 1 if I am correct. Let us try that. Put it on pin 1. I expect it to still work if I run the script now. Yes, it is still working, because if I was correctly, that means that the pin here and pin over there are the same. And let us get the list of pins again, read all. So these are the pins, and the left side here we have the names of the pins, left and the right pins, and those are left and right here. So that's how we can read that. And let me switch this around. Oh, can't switch it. This camera is so unhandy, because I'm just using a webcam as an extra camera. So something like that. Okay. I'm happy that the light is working. Okay. Set pin modes is output. Set pin to high plus 3.3 volt to off LED. Okay. 4 I in pins. And a for loop means looping, and every time it is looping, I think the I is changing. I don't know, it's Python, so it's a little bit new. Program is starting. Global PRPGPB. Right, let us try and get the explanation of this code. Click to Windows, Alt Tab, get this screen. This is the wiring diagram, the thing that we just created. So as you see, 3 lights RGB. The 3 resistors are the 3 that we see over there. And let us read that code. This is the code explanation, the Python RGB LED. Okay, so keep that here in the right of our screen. Okay, what are we reading here? The loop. Also, the function random integer AB can return a random integer within the specified range from A to B. Okay, that's what happens here, a random number for the red, green, blue light. Okay, and then set color RGB. Oh, okay. Oh, now it makes sense. So you create a random number, you create a random color, and then print the color here. This RGB equals RGB here. So that's what we saw here, and it was looping. So that's why it kept saying these these RGB values. Okay, so that's the loop, and the setup would be that we're using pin RGB on a frequency of 2 kilohertz. So 2 kilohertz would be the frequency of the pulse width modulator. Okay. Number of GPIOs by physical location. Okay. RPG start 0. Initial duty cycle is 0. Yeah. And then we change it to a random number, and then we just loop it the entire time. Cool. How can we play around? So these are the pins, but what do all these pins actually mean, man? There are so many pins on this chip. Okay, we started. We make a 4i in pins. And what is pins? Pins is created here, so this is called pins, this for loop. Pins I, GBL. Set pins mode is output. Set pins to high to off LED. I don't know what this code means, man. Whenever we read GPIO here, that means just get it from this import RPI GPIO, so we can ignore that. But why are we using pulse width modulator on the pin R? Pin R will be 11. PR start. PR change duty cycle to the R value. Set color R value, yeah. Where the here we run set color. Okay. It takes a while to understand what actually happens, but it's starting to begin to understand. Okay, so we have a loop. We create random numbers. Then we say set the color to the random numbers that are generated here, the red, green, and blue. These are sent to the word set colors, which is this little script that we see here, and that sets the color. So change duty cycle to the values that we just enter here, and then that's it, I guess. Okay, so how does it work? You start with a setup. You say which pins we are going to use. Do you have common cathode free color LED or common anode free color LED? You're asking me a question, and I'm gonna try and explain, try and answer that, even though it's very hard. Oh, I see that the chat box is a little bit off in the screen. It should be like that. Okay, but how could I see the difference between a cathode and an anode free LED? Because I have this one. It is with 3 pins, but how do I know? I don't even know if I have 2 of the same. Do I have another one? Let me just throw these here. No, I only have one LED here with 4 pins. One 4-pin LED. Are there other big pins things? Not really. Oh, sorry. Put this here too, just to keep it safe. A resistor. There's something else here? No. No. This one too. What's this? This was a infrared receiver. So long pin plus or long pin minus? Yeah, how can I see that? Let me show the information that I have. So I go to Windows again, tab here, Let's go up. Oh. So apparently it says that I have this RGB LED. How can I test that? I'm sorry, I'm so new to this stuff, so I hope I'm not boring you with my noobiness. The only thing I can see is that there is one line that is definitely different from the rest, and that's the second line. We also see it here in our picture, in our screen, and I found it here, but I can't see if this is a anode or a cathode, to be honest. It has 4 pins. The long pin is the common port. Yeah. The 3 primary colors can be mixed to vary colors of brightness. The brightness LED can be adjusted with pulse width modulator. Yeah. You only need to include the header file. Yeah, but we're not using C++. So, does this mean that I should do it the other way around? Should I think inside out? Maybe that works. Let me remove these 3 LEDs. Okay, think inside out. That would mean that I only need 1 resistor, and put that resistor on the we'll just put it inside out, so on the negative one, I guess. So 1, 2, 3, 4. So that thing, a resistor to the ground, but these are all grounds. Okay, think. This is hard. I'm just gonna try some stuff. Get out of here. But I'm using 17, 18. So let's get these 3 back. We're using these 3 to connect to the positive lines. Oh, wrong one. Positive line 1, positive line number 2, and positive line number 3. Maybe this works. Who knows? And connect the other side to the ground. Which means this one should be connected to ground, but I'm scared that it might not be enough. I don't know. Use 2 pins from 4. Test it on breadboard. A long one and short one. Okay, let's test this before I'm gonna do what you're trying to explain to me what I should try. So you were right. I had it. It was inside out. It was upside down. The diagram was not correct. Like you said, I had an anode or cathode. It was inside out. So we learned something new today. What did we learn? We learned that it was wrongly told us. It was told us the wrong way. I had to reverse everything from here. So this diagram that we see here wasn't working. Okay. So what I actually did was I connected this top line, let's call it top line, this 3, I connected that one to one of the resistors that we see here. So we should draw a resistor at the location of my mouse, and I didn't connect that to the 3 port, but I connect that to the ground port over here. Because in my imagination, these GPIO 17 and 27 and 18 port that we see here, these 3 that we're using, in my imagination they were the plus. They were sending electricity to the ground, because we were using that in the first tutorial that they showed us. So let's go back up here with this one, with the blinking light. The blinking light, they teach us to connect it to the ground. So I reproduced this, what we're seeing here, a little bit differently. What I did was I put the resistor after the LED. Is that a wrong thing to do with electronics? I don't know. But I'm glad that it is working now. That you guys are seeing that the light is shining in all kinds of different bright colors. And the color is being generated by this here. Cool. Slowly but steadily we are understanding what we're doing here. Cool. I have a disco light. Very nice. Okay, let's have a short break. A drinking break. Yes, I'm happy that there's actually something happening. We have a shiny light. I never thought it to be this hard, to be honest. But yeah. Hey, you're back. Awesome. Well, I was struggling a lot, and at the moment I have the RGB colored LED working here. You see it. It is shining in different bright colors, and the colors are being represented by this, what you see here in the screen. So whenever we see here RGB, that's just the color. And this is the script that generates this, apparently. I'm trying, I'm starting to understand what actually, what's going on with this Raspberry Pi code. Slowly but steadily. Okay. Awesome. Yes. We have it working. So there was something going wrong with that last script, but I don't want to get into this, to be honest. Let's go back here. Alt tab. Get the Super Starters kit. Okay. What's the next one? Oh, this was the Blink one. Lesson 4. So we have this working. Nice. Even though it's a little bit different. A buzzer. Okay. I'm gonna take a look at this. PNP transistor. NPN transistor. How does this work? If I remember correctly, a transistor is a thing that whenever you give a signal, it would allow signal to be emitted. But why are there two different ones? A P and a N transistor. Okay. Should we read this? Yeah, let's just read this. In this lesson, we will learn how to drive an active buzzer to beep with a PNP transistor. Okay, introduction, the buzzer. And electronic buzzers are direct currency powered and equipped with an integrated circuit. They are widely used in computers, printers, photocopies, copiers, alarms, electronic toys, and blah, blah, blah. That doesn't matter. The difference between the two is that an active buzzer has a built-in oscillating source, so it will generate a sound when electrified, and a passive buzzer does not have such a source, so it will not tweet if direct currency signals are used. Instead, you will need to use square waves, whose frequency is between 2000 and 5000 to drive it. The active buzzer is often more expensive than the passive one because of multiple built-in oscillating circuits. Okay, active and passive. I see one here. A big one. I don't know. It looks like the active buzzer, I think. That's one buzzer, and I have another one. I don't know if this is a buzzer. It's a small round thing. Remove seal after washing. Plus, it has a sticker on it. It says remove seal after washing. So how would I? Okay, so two ones, one with a circuit, one without a circuit. So this must be the active buzzer if we compare it with the one on our screen, and this should be the passive buzzer. I see that my green screen looks a little bit funky at this moment. Can we do something about that? Because I don't like the way it looks. Custom, nope. We see this little green part in front of the screen. Much better. I just had to move the green screen a little bit. Okay. What else is it? Due to the current operating of buzzer is so large that NGPO of RPI output capability cannot meet the requirements. Okay. due to the current operating of buzzer is so large. That sounds like a very wrong English sentence, but let's just ignore it. And I think I understand what they're saying. I think they're saying that the power on these small lines isn't strong enough to actually run the buzzer, if I am correct. So a transistor of NPN type is needed here to amplify the current, the amperage. Okay, the transistor, the full name semiconductor transistor, is a semiconductor device that controls currents. A transistor can be used to amplify weak signals or work as a switch. It has 3 electrodes, pins. The base, the collector, and the emitter, the EBC. Okay. When there is a current passing between B and E, CE will allow several volt currents. Okay. Whenever there is a current passing between B and E, when current between BE exceeds a certain value, CE will not allow current to increase any longer. At this point, transistors work in the saturation area. Transistor has 2 types shown below, the PNP and the NPN. Okay, so I need a P transistor. How would I even know which one of the transistors would be a P transistor? Because I have a lot of transistors like this. I see. Here is a transistor, a small transistor. But how would I even know the difference? How would I recognize it? I feel so stupid for not knowing this. PNP. This one says PN. And what do we have here? I have another transistor here, and this transistor is also a PN transistor. It's the same one. Man, I'm glad that my eyes are working quite well. Well, not quite well, but they're still doing it. Still doing the job. Did I get any other resistors? Stop resistor! Any resistors here? No. So I only got 2 resistors, and these 2 resistors are the same. So I think I am allowed to use either one of the 2 resistors. But it says PN222A. PN222A. PNP. And it says here P, so I'm quite sure that we should use one of these 2. Okay, now what the hell is this drawing here? Is that the passive or the active buzzer? Ah, okay, so now we're changing some stuff. Now we're learning how to use a resistor or a transistor. Because as you see here, this 5 volt apparently has more amperage than the 3 volts. Okay. But which one would it be? The active or the passive one? Does it matter? I don't know. Okay, let us reboot or reset the stage. Put this one a little bit over here again and reset the stage. So let us shut down this code. Now it stops. Now the bright light is not blinking anymore. Cool. Remove all these cables again so we can retry it. Keep one resistor over there. Let's change this code because now we are working with, which one was it? Exercise lesson number 5, the buzzer. But how would I know which one of the buzzers is which one on this diagram? I don't know. Oh, a little bit loud, the music. Oh, I have a comment, sorry. Still don't understand this thing, but I just love watching your assembling things. Having 3 days left, does BTC well gonna go up more? Will it go up more? Oh man, you're asking me a question that everybody would want to know. But I have a bad feeling about the price, to be honest. But who knows? I don't know. I'm not quite sure. I don't think it's gonna grow much more because it has been growing for a couple of weeks in a row. So I don't think there is a big chance of having this happen again. Let us watch this again, because what I usually do is, well, you already see it. I go to bitcoinwisdom.io, for instance. You can use different websites. I always set it on the Bollinger Band, the B band, and I use, well, sometimes this MACD. It's not that important, but I put it on weeks. And if you check this in weeks, you would see that we have a 1, 2, 3, 4, 5, 6, 7, 8 weeks of growing behind us. So there is a chance that it will decline a little bit. I don't know. We just don't know. It is all it is just depending on demand and supply. So the only thing that we know is that the supply will not grow as fast anymore. It will slowly grow a little bit less. The inflation has been halved. That's the only thing that's gonna happen. So what does this mean? I mean that miners will get a little bit less of their coins. So the only thing that can happen is that they have less coins to put on websites like Poloniex, Binance, or whatever the Coinbase websites that we are using today, that are actually used to know what the price will be. So what do I mean with this? The fact that there are already coins on those websites, that's not going to change. The price that they have on the website right now is all built with how do you call it? Demand and supply. Sorry for not being able to say what I want to say, but I don't think that they will change much. The only thing that can change is that people are anticipating on a growing market, and I'm not quite sure that will happen. So we might have a drop of price. But yeah, don't use my it's just my opinion. I don't know. Nobody can know for sure. But I like to think a little bit rational about these things. And one of the things is whenever I get a lot of how do you call it, commercials, or a lot of push notifications that I should buy Bitcoin because the price is going up, then usually I don't trust it anymore. And that's what is happening now, because everybody's anticipating that the halving would mean that it will get more expensive. And that is true. If you look in the long run, it will get more expensive. But on the short run, if you're talking about the price analysis for in the upcoming 2 weeks or 3 weeks, I think it's going to go down. I think if we're talking about the upcoming 2 years or 3 years, it's definitely going up. So if you want to be a long-time hodler, then any time is the right time to buy, unless you hear about Bitcoin on your local news. Because whenever you hear on the local news, then you should start selling. That's some of the things that I've learned in the last couple of years. Okay, let us try and build this diagram. Just try something. Okay, so we need a connection to the 5-volt, so let's start with that. Let's put the 5-volt here. Can you guys see it? I don't know if you guys can see it because I'm not looking with you, so put this a little bit back over there. The reason why I put the screen all the time here is that it's easier for me to go back to Windows and open that screen. So what are you guys seeing? Okay, you see me connect stuff. Nice. Alright, so this one, and this is a wrong resistors, because this one was the 10 kilo ohms. Now I need 1 kilo ohm. So how do I get 1 kilo ohm? Here on this list, this tells us how to read these resistances. And I need to have a 1 kilo ohm, and it says here that it has a orange line. So that's one of the main indication, main help that I'm getting here. And I see here, give me a sec. I only see one of these resistances that has a orange line on it. That's this one, so I'm quite sure that I should use that. 1K should be on the first place. Ooh. I don't know how to read these things. How does it work? There's 5 lines. It's so hard, just because it's so new for me. I wish there was somebody here that says, oh, just pick that one, that's the right one. Here we have one with orange as well. So I have an orange fourth line. Yes. The band code, it's just 1. Am I right? Brown, black, black. 100 times the 1k ohm. Okay, so I think I should have this one. God, it's so hard, man. It's so hard to do this. And it says here that it should be connected to the 17 port over there. So let us first choose a 17 port. Let's get this line. Put the orange in port 17. Okay, 17. Just like we see in our diagram. It's connected to number 17. Maybe I should turn this a little bit like that, so it makes a little bit more sense. So, as you see, this blue line represents in the screen this upper line here. See this one? It's connected here to the 5 here on the right. Bruin, zwart, rood. Bruin, zwart, rood. Bruin, zwart, rood. That will be the 1 kilo ohm. Bruin, zwart, rood. Let me search for bruin, zwart, rood. Oh, sorry, that means brown, black, red. Bruin, zwart, rood. Yeah, I'm repeating myself so I don't forget it. Bruin, zwart, zwart, rood, rood. Bruin, zwart, zwart, rood, rood, rood. This is so hard. And it's also very very small to see colors on these things. You see, well, you cannot see it bright in our screen. You see it over there? Not really. Too bad. Well, you get the idea. Bruin, zwart, rood. Bruin, rood, zwart. Brown, brown, brown. Yeah. Let us try this one. And put that one somewhere. So port 17, let's put it over here. Let's connect this one resistor. These names, man, I don't like all these names. Put it over there. Can you guys see what I'm doing? I think it is a little bit overexposed. But yeah, we have it over here. This resistor would be what we see here in our screen. Let's connect it to our, what was it called? A transistor. And I think I have to, I am supposed to connect it to the middle one. Yeah, so let's do that. Let me put these pins a little bit to the left and to the right. And then put it. Yeah. So now we have the middle pin connected to this resistor and then connected to port 17 here. Or it's called pin GPO 17. GPO I7, maybe that's it. No, it's not like that. I don't know. Okay, then it says to put one of these lines to ground, but which one? Let's just pick the most right side now and put that to ground. So the most right side, like we see on our screen here, the yellow line to the most right part of our transistor. These names, man, I hate these names. And put it to ground. Where's ground? G and D, ground. Okay. And then the other side of our twisted transistor should be connected to our sound making device, our buzzer. Doesn't matter. Is there a plus and a minus on the buzzer? Yes, obviously there is, but how does it work? Oh, it says it on the top. It says here, it shows us a small plus. You can see it here as well. So this longer pin should be the plus pin. Okay, so let us just put it somewhere on our breadboard. So plus. How long is the distance? 4 pins. Okay. This would be the plus, ground should be connected to which part? I'm confused. Let's go back to this line. So this should be connected to the minus part, if I am correct, and then the last part would be the plus part, this blue line. So come on, let's hope it is working. Okay, I think we have the schematics working now. Is correct. Final check. In the ground, in port 17, in 5-volt. Yeah. Okay. Let's try and run this. It was number 5, so let's go back. cd // and open 5, the buzzer. And let us open the script here as well, because I'm curious. Python code, the buzzer. Let's open this buzzer. Okay. Buzzer connecting, make buzzer beep. Okay, this is the program. We see we're using the beep pin is 17, and that's everything. Okay, so what actually is going on? We have a beeper connected between ground and between 5-volt, this blue line and this yellow line. And usually it should be on the entire time, but it is not going to be on the entire time, because it will only be on if the transistor's middle pin is connected. So that's what's going on now. And apparently we are beeping this by sending a signal through this orange line. Okay, we're gonna see what's gonna happen. So let's run Python on the buzzer. I think it's called buzzer. Press enter to begin. It's working. Nice. Stop it. It is very annoying. I know. It is an annoying sound, but it is working. So slowly but steadily, we're starting to understand how this works. And Haney Heatland says brown, black, red, or brown, black, black, brown if 4 or 5 colors on it. In this case, it is a 5 colors. I only have 5 color resistance, and the one that I'm using at the moment has brown, black, black, and then a fat line red and a small line red. I don't know, but apparently it is working. So I'm very happy, and thank you for the information, and it's very nice that you were sharing this. Awesome. We got another one working. The Raspberry Pi is starting to work a little bit. We're getting into it. I know it has been a little bit hard and a little bit boring, maybe, especially at the beginning, because nothing was happening and I was trying to figure it out, but I'm getting happier by the moment. Yeah. I'm so happy. I'm happy that I'm starting to understand it a little bit. Okay. Let me rerun it again for fun. Yeah, it sounds like a fire alarm. Yes. Okay. So let us check the code of this buzzer. So what we see is when it starts, the program is running, it's just going to print this message. And well, we see it over there. And what's going on then? Okay, we start by saying a pin 17 is the one we use. We start to run. Then there is a setup. Set the GPIO modes, set modes, and what is this? GPIO BCM. What does it mean? Let us grab the what was it again? The tutorial list. Maybe they can explain it a little bit more. So let's go back to the Python script. The B pin. Are they explaining something here? BCIN? No, I don't know what. To B. Oh, set the GPIO modes to BCM numbering. So there are different modes, but I don't know yet what these modes mean. So it says here we're setting it to numbering, and then set the lab pin mode to output. Yes. So the setup would be that B pin 17 is a output. Our initial is GPIO high. So if you would say GPIO low, then it wouldn't start with a sound. Let us just try for fun. Save it and rerun the program. Now it starts silently, and if I press enter, it will start beeping. Nice. Cool. Why does Litecoin not even up ASF? ASF. I don't know. But why does Litecoin not even up? What's going on with Litecoin? What do you mean? Let me check the coin market capitalization. What's going on at the moment? Litecoin. Show us Litecoin. I'm interested in Litecoin. I think we just need to give it some time. I don't know. I don't know what it could be, or what it should be, what it would be. I don't know if you guys have any idea what can go on in this crypto community, why we have these pulses. I don't know. Litecoins are left behind. Yeah, well, maybe in the near future. I'm not quite sure. The thing that I do know is that Litecoin is a coin that still being developed. Very, how do you call it? There's a lot of people working on them. And those are the same persons that are also working on the Bitcoin source code. So that's one of the things that I know for sure, that the Litecoin will stay around for a long time, because yeah, they are involved in both projects. But that's all that I know. And why is it behind? I don't know. Why don't people care about that coin? I don't know. And I wish I knew. Okay. Let me check. I never added a description for my live stream. I just get that message. Let me quickly do that. Where is? Oh, I don't have Notepad++ open yet. Sorry, I'll be back with you in a second. Stream list. This LAN that we have here. Copy it and make it the description of our live stream. So, sorry. Okay, but Litecoins, man, yeah. Why wouldn't it grow? I think it will grow. If you look at this here, it will eventually start growing again, I guess. I'm not sure, but I have this hunch feeling. Well, yeah, but we are still in the rebound. That's how I think of this time of crypto that we are in at this moment. I get the feeling that it is still a bearish market. Are you holding some Doge coins? Some Dogecoin. Doge. Well, I'm always holding some Dogecoin, and these Doge coins, I call them Doge coins. I know a lot of people making fun of the way that I'm saying this. I call it Dogecoin, but it's Dogecoin. But hey, I see my brother is watching my live stream as well. He just sent me a message. Well, it was an hour ago. But yeah, I am holding Dogecoin, and I always use Dogecoin. I don't know if you can see it on my background of my mobile phone. And it is for me an indicator, because I always have this idea that whenever Dogecoin is growing, all the altcoins are growing too. And when Dogecoin is, how do you call it, shrinking in price, then that's too. But we shouldn't think of prices that much, man. It's not about prices, because you should never be the person that wants to sell his or her coins. You should hold them, and you should spend them for things, and not for dollars or euros. That's just what I think you should. It's not exact science, obviously, but yeah, you should think about keeping it and never think about prices. Just collecting more Bitcoin. That should be the main goal of us. And spend it when we're old. Spend it on well, old people stuff. Okay. So making the buzzer beep. So what we did now was we gave it the initial GPIO low. Okay. I'm trying to understand. Yes, right. I lost all my doggy coins. 1.5 million doggy coins. Oh, that's a lot of coins to lose. Man, I feel sorry for you. Okay, GPI low, the buzzer on, buzzer off. So I wish I just traded it or swapped it to Bitcoin. Man, so you don't have any access anymore? So you lost it completely, or what happened? What was actually going on? Because did you lose the private key? Did you lose the access on an exchange website? Did you lose the access to your own wallet? Did you have it on a mobile phone and you accidentally threw it away? We might all did that. Or did you lose a lot of cash because the price was going down? Even though I don't think Dogecoin was going down that much in the last couple of weeks, I could say. Oh, wrong computer. Where is that screen? Here? Is it this one? Yeah. The coin market capitalization. I can't access it anymore. So you can't access it on your own computer. Was it your wallet.dat you cannot open? Was it a backed up wallet, with a 12 word backup phrase backed up wallet, something like that? Because there are so many different ways that it could be the case that you cannot reach your coins anymore. Dogecoin, how is Dogecoin doing? Slight grow. I'm using Doggy Chain wallet and I lost the key. The Doggy Chain wallet. Which one is that? Is that the original? Is it the core wallet or not? I think it is the core wallet. Because have you tried the tutorials that I have created in the last couple of years? Well, that was a year ago. Yeah, I hope that you one day get the access to the wallet back again. But yeah, that's the one. The original. Yeah, I think you have the official Dogecoin wallet, if I am correct. Just the official wallet from the Dogecoin website. Doggy Chain info. Or did you use? Or you made an online wallet? That could be one too. Now I'm broke. Oh, I feel so sorry for you, man. I think we're all broke. We're all a little bit broke. I'm sorry, man. Sorry to hear that. Oh, nice commercials. Refresh. How many blocks yet left? Only 332 blocks. It's only 3 days. I have no clue what's gonna happen, man. I'm so curious. Especially now that COVID can work. Oh, that's what you mean. Because of the COVID-19 pandemic, you can't work and you cannot make any money. Oh, that's so terrible, man. I feel sorry for you. We're all having a little bit of stress because of this COVID-19 stuff, and I hope we will get better. Oh, I'm so curious. Let's check out now while we're here, because I'm a little bit bored with this Raspberry Pi. Let's check out how it's doing, the COVID-19. I'm just curious. This full map. So lots of days. Oh my God, United States. It's going terrible, man. Oh. Cases per 1 million people worldwide, 500. United States, 4,000. Whoa. That's 4%. 4% of the United States. What? In the United States only? And it's mainly focused in New York and I don't know, the district around there. Whoa. And how is the Netherlands doing? Deaths 5,000, recovered. They in my country they just stopped the recovery checks, I guess. They quit telling everybody because it was too much. They were like, yeah, we can know for sure how many people are recovered, so let's just stop calculating it. But yeah, the United States is number 1 greatest country in the world, as you can see. Nice. I was supposed to go on a holiday to the United States. But yeah. Okay, let's just forget about this stuff. I know. It is a little bit boring. Do you know some way to earn money online? Well, How would you earn money online? I wish I would. I wish I knew. To be honest, I'm just thinking. I think you can scam people, but you should never do that. But how would you make money? Sorry, to out topic your stream. I don't mind. I don't mind because sometimes I just don't know what to do in the live stream, and I'm just doing something. And whenever I get somebody asking me a question, then you're guiding me a little bit in this live stream. And usually, when you have a question, other viewers have questions too, because most of my viewers have kind of the same personality. You love my videos. Well, I'm so happy that you do like my videos. That's very nice. Nice to hear. I do my best to inform people and at the same time entertain you a little bit. So I'm trying to make infotainment. That's what we call it. Okay, but yeah, let me chill out a little. I need to stand up. My legs are hurting. But yeah, how is my live stream doing? Can you guys see me? Can I see anything? Yes. Okay. Okay, can you guys give me a couple of minutes? I need some drink. I need to chill out. Oh, I have drinks here. I have some, how do you call this? Lemonade. Yeah, I know you want legal ways. We all want legal ways. Well, I have a YouTube channel with lots of tutorials. Doesn't make much money. So, how else would you be able to make money? I don't know. You can do a sex change and videotape yourself and be like that. I don't know. But no, I have no clue, man. I wish I knew. If I knew, I would be more rich. But if I would be more rich, you guys wouldn't even see me, I guess. This is my doggy wallet, a new one. Yeah, you can share the wallet, and hopefully somebody in the stream would want to donate something. But to be honest, I have noticed that a lot of my viewers aren't very generous and aren't very rich. So chances that somebody is gonna donate are none, I guess, because nobody donated me. Well, not nobody, because there were a couple of persons, and but oh, you're not asking for donations. Oh, you're showing off your wallet. Okay, check the doggy chain. Come on, stop messing around. Doggy chain results. Type and search for that wallet. It's an empty wallet. It says here it's empty. There's nothing left in that wallet. No balance. But you did receive a 500,000 doggy coins. Okay, maybe for earning money. You can start streaming like I'm doing, but doing it on a other platform. How else can you make money? You can try and program an app for for the Android market. Make a game, something like that. What else can you do to make money on the internet? It's so hard, man, to make money. You can maybe you can become a teacher of some sort of things and make personal lessons that they can connect with. How do you call that? I want to say Zoom. That's what it's called. That program, Zoom. Yes, I lost that 1.5 million. So how did you lose it? Because apparently it says on the blockchain that that address that you were telling me, the 1.5 million doggy coins, has been emptied. So did you empty it or did somebody else empty it? Let's begin with that. That's a main question. Was it here? Where did I do it? No, it wasn't in this screen. So many screens. Was it here? No. Wait, get out of here, coronavirus. Let's go back to the doggy chain. The doggy chain. Here is that address. And it says here that it's empty. And transactions. Amount. So it's not that long ago. 4th of May. That's only a couple of days ago there was a transaction. I see here a plus minus. What's going on here? I'm not that familiar with this blockchain, this website. So let's check the latest transactions. It did send input output. It sent it to this wallet. Is that your wallet? I don't know. That's how I usually try and figure out where my coins had went when they were gone. Okay, but let me try and check out a little bit more in this Raspberry Pi idea. This Raspberry Pi, but let's check out. Oh, damn you! No, come on! No, it's the. No, I don't need that. I need the Super Starters kit. And what else do we have? We have a DC motor. Streamlabs. Oh, sorry. DC motor. We have that. We can use that. Let us check about this lesson. We have a small power supply and a module. The small DC motor is likely to use more power than the UNO R3 board digital output can handle directly. If we try to connect the motor straight to a UNO R3 board pin, there is a good chance that it could damage the UNO R3 board. So we use a power supply module provides power supply. Wow, these English sentences are so terrible sometimes. I cannot believe that this tutorial PDF file is written by somebody from the United States or England, but that doesn't matter. Okay, my back start to hurt a little bit sitting here the entire time. Setting up output voltages. Okay. Whoa. I'm just gonna read through this. Let's put this over here. Just checking it out what we have in here. Because it's getting harder every tutorial apparently. And here we have rotating motor. Left. And so clockwise and counterclockwise motor. Okay. Motor 2, motor 1 direction. Okay. It's totally different, man. This is a different kind of connection. So we need this module apparently. Okay. But for what? Where do we connect this to? Because we're talking about a 5-volt connection, but where is that 5-volt connection? I don't know yet. Ground 1, ground 2. Red is VCC 2, VCC 1 here. It's connected to 5-volt. Would that mean that I have to connect it to the 5-volt here on my breadboard? Because we're not seeing it here, that it should connect to the 5-volt exit here. Hey, Sam Iskandarani just subscribed. Hey, that's my dad. My dad just subscribed to my channel. Hi Dad, welcome. It's awesome to have you here. At this moment I bought this Raspberry Pi starters kit and I'm just messing around with it, trying to figure out what this actually is, what I'm working with. And I'm seeing that this is a DC motor and we need a special chip for that to work. But I am kind of confused at this moment because it says here that it needs to be connected to a 5-volt in this diagram that we see here. But the problem that I have is that I don't know which one. I see that I have a DC in here, this one here. So I think this is a direct currency 5-volt entrance or something. What I did get was I got this. Oh, sorry. It is a cable, as you can see, which can be connected to a 9-volt battery. So this is confusing me big time at this moment. Because I know that I can connect these two together. Let me show you, like this. But then it would mean that I should put a battery, a 9-volt battery there. But we don't see the 9-volt here in our diagram in our screen. So I'm a little bit confused now. Why? Why is it doing this to me? Very confusing. Extra power supply on the left side of the paper drawing. You mean this one that we see here? I see a ground here, and I see a connector over there. So I think you're talking about that. Let me see. Yeah, that must be the case, because we see a plus here. So do you see my mouse? I know it's very small in our screen, but I know that I see a plus and a minus here. Let me zoom in a little bit. So the H for hand, now hand. So we see here a plus and a minus. So that will mean on the board, let me zoom out again. This line here, so it says that we should connect it. Oh, you cannot see it that well. Oh, mess around, let me mess around. I should connect it something like this. But then still I have this main question, and that is, where does it get the extra power supply from? Because I'm afraid that I might destroy my stuff if I don't have the right connectors. So I'm a little bit scared at the moment to install this stuff. Plus and minus. Brother, can I post my Bitcoin wallet if you don't mind? Maybe someone can help. After this COVID, I'll be back to work, so my life go back to normal again. Of course you can try if somebody will help, but don't get your hopes up, because I have a channel with I think it's already 300,000 views, and I never get any donations. So I'm don't get your hopes up, man. Don't get your hopes up. That's all I want to say. I'm sorry, man. I wish it was very easy. Okay, let me allow it, because usually it is not allowed, but now it is allowed. So if you are a viewer and you want to help another viewer out, go donate. Go donate to his channel to his address. Okay, let me think about how I could do this, because I'm a little bit scared. You say I should use this outline for the 5-volt. Let's check what they are teaching me up here, because there was a lot of information here that I skipped. Okay. Input voltage 6 to 9 volt direct currency. Okay, so that's what I need. So I actually need a battery. Okay. But I don't have one of these batteries. I don't have. Let me check. I'll be right back. Look, I have normal batteries, but I never use those big batteries. Even kijken, batterijen. I didn't know. Okay, I can't find a battery this fast, so That's our battery clip. Yeah, the battery clip. What I can do, but I have a yeah, what do I have? A 6-volt regulator somewhere. Let me search. Better to use adapter power supply. Yeah, I was searching for that too. I have it. Where is it? Search. I was using it for something different. Whoa, 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 whoa. Where could it be? Is it here? Is this it? Yes, I have this. A power supply which I can put to 6-volt or to 9-volt. So let's be smart and put it on 6-volt first. Even though it says here 6.5 till 9-volt direct currency. So I can also put it on 7.5. And it is direct currency what I'm having here. Like that. And you see it is these ports. Does this fit? It does fit. Is it the same kind of fittage? Let me search. Ah, that's very nice that we cannot see that. What am I searching for? Because I know that there's a plus and a minus on this direct currency, and I can see on this plug here, I don't know if you guys can see it here. I see minus and a plus, and that means which one of these irons here is the plus and the minus, the outside of the inside. Should I just try it? Good luck for that Raspberry Pi thing. I don't understand what it does. Man, I don't understand what it does either. All I know is that it is a small computer. So that's just it. This thing that we see down there, that is the computer. It's just simply a computer. It has a here it has HDMI out, 2 ports. You see that? These two. Here there's a jack out. Down there, I don't know if you can see it now. I have to use my hands, but here is an SD card. Let me try and show it. You see here an SD card. That's where the operating system is installed on. So it's just a simply SD card. What do we see here? This cooling thing is the CPU. Here is the 4 gigabytes of internal memory. And what else do we have? On the other side, let me try and show you. It's a little bit messy, but well, here you see USB 2 ports, and USB 3 2 ports, and here is an Ethernet port for internet. And oh, I forgot to tell you here. Let me show you here. This chip that you see there, this little gray chip here, that's the Wi-Fi. So it is connected via Wi-Fi. And let me move this screen a little bit down here. Here you see the Wi-Fi logo in the top of our screen, and that is just well, the Wi-Fi that it receives through this chip over there. So that's what we're working with a small, very small motherboard. It's just a simple small motherboard. And why am I using this? Because it has the possibility to connect this beautiful rainbow colored cable to this breadboard. And this breadboard is a board where you can practice electrotechniques. So you would try and make something on a breadboard like this, and later on you would create a real print plate. I don't know if that's the right word. We will call it a print plate. What I'm talking about is one of those green things, you know. You can make them. You can't see what I'm showing you. Let me open this. Doesn't matter. So whenever you see these things, just a green plate with computer chips on it. So let me show it on the other camera. When you look close on it, you see small lines on it. These are very small lines, and I'm gonna show you here. Here we see them. Small lines, lots of small lines. Here they're walking from left to right. Here are some lines. See, they're going from there all the way here. And these lines that we see on this plate are nothing different than one of these cables. But it's very nice ordered together, because they know for sure that this is the layout or the print that they want to make. So you can remake this print on a board like we have over here, and it will be just very messy, but you can train and practice, because once you've soldered something on a real plate, you cannot change it easy anymore, because if you want to try and change it, you might burn your plate. So that's why we use this thing. And why are we using this? Because the cool thing is that we can communicate using the command window with scripts, and we can give we cannot only give information out of this board that we see here where my finger is, we can also receive information. So I have this big set, I bought it today. It has many different parts. It has for instance, a remote control. I haven't used it yet, because if you want to use a remote control, you have to use an infrared receiver. So these work together. Oh, let me try and show you. So we have a receiver here, and we have a remote. And well, if you want to work with something like that, you have to learn how to program, and you have to learn how a computer would interpret something like that. And so that's why I bought this. So I would be able to learn how to make a robot, because essentially you can make a robot from this, because you don't have to have this operating system open like we have at this moment. We can just shut it down. Well, not shut it down, we can just ignore it while a Python program runs on the background. And what kind of programs could you be thinking of? Well, for instance, I know that this that we see here, this is an ultrasonic, how do you call this, receiver, I guess. So I don't know what it does, but if I would use, if I would think what it would mean, an ultrasonic thing would be how it uses on one of those, how do you call it, a vacuum cleaner, those robot vacuum cleaners. So what am I thinking of? Tesla cars, you know, they have ultrasonic, they would see if something is in the way. I think one would send a sound and the other one would receive it or something, I don't know. But then you can program something. And what would be that something? For instance, well, one of those robots riding and trying to hit a couch, and whenever it sees a couch too close, then it says turn right, something like that. You have to program it. What was I trying to... Well, I wanted to go on the internet to show you guys something. I can't remember, I'm sorry. I was talking too much. I have that. I have a very ADD mind sometimes. Okay. But oh yeah, I wanted to show you the garden robots. Something that what I was talking about was a garden robot. In case you guys don't know what I mean, one of these things, those robots that drive around themselves. So I think, I'm not sure, but I think theoretically we can make one of these things if we would have a DC motor running, and a DC motor connected to a wheel, and if we have, for instance, infrared sensors or ultrasonic sensors, something that can sensor that there is something in his way to know if it should turn left or right. Distance. Oh, is it used to calculate distances? Is that what it is? Well, that might be the case, because I haven't. I just bought this Raspberry Pi yesterday. I pre-installed it yesterday. I did receive this Super Starters Kit today, and I only thing I did was an unboxing video. I recorded this, so if you are here now, next week I'm gonna upload the unboxing video. I haven't edited yet, but that is all that stuff that we see here. This breadboard and all these chips and stuff, and all this messy stuff that we see here on my on my desk. Very messy. But yeah, let me reset the breadboard, because this beeper, it did work. Nice. Reset the breadboard, because I want to use this DC motor, and I was advised to put net control. So I have here net control, and the reason why is because it needs a lot of amperage, I guess, to run the robot, which cannot be provided by the chipset that we see over here in our screen. This chipset here, it doesn't have the power. So let me figure out where I have an extra power outlet. Oh, that one isn't used for my light. The Raspberry Pi. Come on. Okay. Give me a second, you guys. again. Power outlet. Be right back. Still here. I'll move to the other side of the room. Getting a power outlet. Still here. Sorry for being at the moment. Power supply. Let's make sure I have it on 7.5 voltage. Or should I put it on 6? It says that it could until 9. So I have here a power outlet and it has 7.5 voltage on it with 1 amp. Please don't die. I think I was. I don't know what's going on. Can you guys see this? No, you cannot see what's going on. I did just. Well, it's not install, but I entered it, and we see a green light going on here. Even though this button isn't helping, but we can see that there is something actually happening. Okay. I don't know. Let me sit down again. Let's get back to the microphone. Yeah, same as on the back of a car. Ah, okay. So it is just a distance calculator, the ultrasonic. I didn't know that. Thank you for clarifying that to us. Okay. Drinks. Get a little bit of hydration. The Fallout robot. Yeah. Okay. The DC robot here. So we put this somewhere in our screen. Okay, the DC motor. Oh, this robot, come on. This camera is a little bit off. So the robot, we have it here. This is the plate that we see on our screen now. Okay, I'm gonna read this. In this lesson we will learn how to use the L293D to drive a direct currency motor and make it rotate clockwise and counterclockwise. Since the direct currency motor needs a large current for safety purposes, here we use the power supply module to supply motors. Yes, so we're using a different power supply. Okay. Breadboard power supply. The small DC motor is likely to use more power than we can handle. Yes, we already had that. We have a locking on or off switch, but I don't get it. We have a switch. It's going on or off. Okay. We see something working. And put it a little bit more in our screen. So here we have a button. I don't know. It's for 5 volt. Product specifications, independent control rail. Yeah, okay. So we have 2 rails here. So what we see here on our breadboard, we see a red and a blue line. The red means plus, the blue line means the minus, and all these lines from front to back until the half, so until here, all these reds are connected together and all these blues are connected together, and all these blues are the minus and the reds are the plus, and the same principle applies for the other side of the breadboard, but only until the half. So these reds are all pluses and all these blues are all minus. And I see here, like they're telling us here on our screen, which is the 5 volt or 3 volt option. So I think that's important too. Okay, so the left side and the left and right voltage output can be configured independently. To select the output voltage, move the jumper to the corresponding pins. Yeah, that makes a lot of sense. So, and in the middle would be off. So you put 5 volt, 3.3 volt. So that's just moving this pin here. That's not that hard. Nice. Okay, note power indicator LED and the breadboard power rails will not power on if both jumpers are in the off position. Okay, doesn't matter. So we have 3 volt here and 5 volt there. So let me first put it to 5 volts. So as you see, I switched this yellow socket on this side to 5 volt, and here we have it on 3.3 volt still. Okay, important note. Make sure that you align the module correctly on the breadboard. The negative pin minus on the module lines up with the blue line minus on the breadboard, and the positive pin plus lines up with the red line. Failure to do so could result in accidentally reversing the power to your project. That's not supposed to happen. Let us first start by making sure that we have the right chip. So I got several different chips. I have a chip here. I see another chip here. L293D. Oh, I think I have the correct one already. That one. And what does this one say? GM something? No. What is this one? GM195? No, it's not this one either. So this is the right chip, apparently. Hello. Okay. This is a very useful chip. So we're talking about this chip that I got. It's a very useful chip. Is there any difference in how you should hold it? We see that there is a dent here, so that should be how we know the top from bottom. We see that here in our camera screen too. You see? Small dent on this side. Okay. So what am I supposed to do with this? Featuring the L293 products from Texas Instruments. Texas Instruments! Hey, they made my calculator too. Wide power supply range, from 4.5 volt to 36 volt. Okay, nice. Separate input logic supply, internal ESD, thermal shutdown, high noise, blah blah blah, doesn't matter. Output current 1 ampere per channel. Peak output current 2 amperes per channel. Oh, nice, 2. Okay, I don't even have 2 amperes. Okay. So this is the chip. The L2 something D. Okay. But where is the top and where is the bottom? Are there numbers on this chip? There isn't much on it. I'm sorry that you guys can't read what's written on this chip. Oh. It's not in focus. Too bad. Okay, let's go down. Description and ordering information. Well, these chips are quadruple high current half-H drivers. It's designed to provide bidirectional drive currents up to 1 amperage at a voltage from 4.5 to 36 voltage. Okay, it's designed to provide blah blah blah. It's the same thing again. It's used for designing drive inductive loads such as relay, solenoid, direct currency and bipolar stepping motors, as well as other high currency, high voltage loads in positive supply applications. All inputs are TTL compatible. Each output is a complete totem pole drive circuit with a Darlington transistor sink with a pseudo Darlington source. I have no clue what I'm actually saying here. It's all new. Drivers are enabled in pairs with drivers 1 and 2 enabled by 1,2 EN and driver 3,4 enabled by 3,4 EN. Oh, 1, 2 enabled driver. When an enable input is high, the associated drivers are enabled and their outputs are active and in phase with their inputs. When the enable input is low, those drivers are disabled. Damn, it's so much information. The block diagram. 1 to 16. But where does pin 1 start? Ah, here we see something. So I should have known this, that pin 1 starts, well, I think you should, the notch up. Well, notch up, pins down, left side, upper pin is pin 1. Notch up, so, okay. We see here, pin 2 is connected to the plus, if I am correct. Oh, okay, pin 16, battery plus. Am I correct? Plus, here, yeah. 16, and we see a minus connected here to the 4th ground. Yeah, okay, now it makes sense. Okay, we're going to put this on our breadboard. I'm just gonna do it like they say here. So somewhere, make sure all the pins are connected on one side and on the other side. Come on. Okay, we have a chip in place. Yes. Okay. So we need 5 voltage on this side. Let's just put it all on 5 voltage. Start with that. So both sides are on 5 voltage here. Here should be a 5 voltage connector. So a very short cable. Let's grab the red cable and go from the plus line, here the red line, and connect it to the first port, this one. So we did connect, if I am correct, this one of this line, this red line here. Oh, and it wants us to connect it another time. It says here, connect to VCC2 as well. But we don't see that happening here. It's a little bit different. This diagram is a little bit different, am I correct? Well, no, not. You see here, on the first connector, 1 to EN, is on 27 here. So we see the orange one is connected to the first one. This line is going up, over to the right, connected to 27 here. Okay. Let's do that. So let's copy what they say here. Let's grab an orange line to do this. A long orange line in this case. Here we have a long orange line. And it says connected on this side of the chip. Let's go around and connect it to which one? To 27. Here's 27. Doing this right? I have to check from the top. Yep, it's 27 because I can't see it 100% right from here because I'm looking from an angle down, and well, you might notice from driving a car that when you're in the passenger seat that you don't know exactly how fast you are driving because you're looking at it from an angle. Okay, so that was the orange line. Orange one. So what does this mean? Nothing yet. We aren't connected yet. Only thing we have is we have an input on 1 to EN. Okay, and we have a power supply in. Okay. And 18 is connected to 1A. Why? Okay, let's do that. This is this purple line. Do we have purple? No, we do not have purple. Let's grab blue. So it says grab the second one. Second pin. This pin. Notch up. Turn off power adapter first. Hey. Smart. Thank you. I didn't think of that. Okay, the second one goes to port 18. That's here, number 18. Sorry that my hand is in the way. 18. 18 is connected to the second line. Okay. Then the third one is connected to the minus of the DC motor. So let us grab the DC motor first. Where is it? Here I have a DC motor. It's still packed. Come on. So here we have a small DC motor. And I'm not gonna. I have a fan here as well, but I'm not gonna put it on because I'm scared that it might start moving around too much. How would I? I'm just gonna put the DC motor here first. So It's a direct currency motor, so it should not matter which part is plus and which part is minus, if I am correct. And if I am wrong, then I'm just an idiot. Okay, on the third pin, one, and another one on the third pin from the bottom. So, let's see, 1, 2, 3, here, this is the third pin from the bottom. Sorry to be in the way. We have our DC motor here. The third pin on the bottom. Okay. So what do we have? We have this line, this one over there. Here we have one. The green one is connected. In this case, it's this black line that we see here. Then we need to connect this to ground. Okay. To ground. And it says here that we should connect the ground from our Raspberry Pi to the ground of this one. So the ground here should connect to that ground, which is the blue line over there. So let's do that. Let's keep ground in, well, is it green? Usually it's green or something. Upper power jumper is on and not 5. Is it true? This one says 5-volt and this one says 5-volt too. Here, look, you can see it for yourself. I don't know if you can see it, but I am expecting you to talk about this bands here, these two, and they're both on 5-volt because that's the right side is 5-volt, and otherwise it would be 3-volt. So I think I have them on 5-volt both. If not, please correct me if I am wrong. So this ground should be connected. Let's connect that first. So grab the ground here, ground wire, and connect the ground to this minus over there. So that will be this line here is now connected. Correct the ground, yes. Okay, then we need a ground connected to this chipset. And these are those two lines. Here we see double ground. So let's do the double ground. I'm gonna grab let's use yellow for the ground again. Another ground and another ground. 2 grounds. So what I'm supposed to do is pin number 4 and 5. So let's check again. 1, 2, 3, 4. 4th and the 5th. So 1, 2, 3. Well, it's these two here. Nice. These two should be connected as a ground. That's what we did now. I hope you guys can see. And then connect one of these grounds, should not matter which one, to the other grounds. So we have these lines now. And what is this? 17 should be connected to the second from the bottom. Okay, let's do that too. Let's grab a orange line again. So let's put this orange one in the 17 here. We keep using these same ports. You start to recognize that you keep using the same ports. So the 17, 18, 19 or something, these ports are used many times. What was I supposed to do with this? To the one from the bottom, not the bottom one. One from the bottom. Okay. That was this line, this green line here. We have just connected this correctly. This line number 27 is connected to the top over there. That is correct. Number 18 here. These are the same 3 lines that we previously used for the RGB, red, blue and green LED lights. And they were controlled by these 3 cables. This one here and these 2 orange ones. Okay, so those are different controllers. Well, it's not a controller, but we can control stuff with it. Okay, it says that I have to put the 5-volt on the bottom here too. So let's do that too. A red cable for indicating that it is a plus. The one on the bottom the final one. Wow. we have 8 connectors. Yeah, that's correct. Here, 8 connectors on one side and 1 connector on the other side. And these connectors should be together. So I can put this one together with the other red one. Okay. So if I am correct now, I have the right diagram now. So it should work correctly now. I don't know if you could see what I did, but I think it is working correctly right now. Let me recheck. It doesn't matter. I believe it. I believe I did what I was supposed to do. Put this screen out of here. Let me give a little bit of space. So, does this mean that it should work now? Test instructions. This project is designed for learning how to use buttons to control LEDs. We first need to read the state of button and then determine whether to turn the LED according to the state of button. We don't even have LEDs here. What is he talking about? We're talking about a robot. Stupid copy paste stuff. Okay. The DC motor will turn for 5 seconds and then stop for 5 seconds. Then for another 5 seconds it will continue the process. Okay. Let's remove this. And let's try it out. We need power supply. Please don't explode. Oh, I heard the motor starting. I don't know if that's supposed to happen. Let me first go back to unfold it back. List all the tutorials, and it's the 6 DC motor. So CD 6 tab, enter LS for listing, and then Python on the DC motor. Let's open that file before we run it. Python code, the DC motor. So this is the code. Pin 17, pin 18, motor enable 27. The pin. Which one is pin 27? I am a little bit confused now, because I see here motor pin 1, 2, and then 27. 17 was with this RGB LED. Oh, it's using pin 11, 12, and 13. Here 17, 18, 27. I am confusion. Why am I confused now? Because I see here motor pins 1 and 2, 17, 18, and I expect that to be the points here on this board, because that's what it was here. The pins were 11, 12, and 13, which were 11, 12, and 13. These 3. And now all of a sudden it says here 17, 18, and 27. So what's going on? Clockwise, counterclockwise. Let us try and run this script. Let us check what is happening. Program is running. Press enter to begin. Sorry brother, can't go for long, too sleepy now. I need to go to my neighbor tomorrow to ask for foods or for at least one day. Oh, it sounds terrible, to be honest. Good night and keep uploading videos. Well, I will keep uploading videos, and I hope you have a good night too. I do hope you have a good night, man. I'm sorry that it's running too late. I don't know where you're from, which country you're from, and what time it is at your country. But if it is just the same time as here, it's 11 p.m. here. It's getting late too. So, yeah, I hope you sleep tight, man. And very thankful for having you here, man. I really appreciate you being around and sticking around for that long. Well, thank you, man. And I hope you have a wonderful night, and see you in a week, I guess. I'm trying my best to upload weekly, or to do something for this community weekly, on a weekly basis. Okay, let us check, because now I started I plugged the direct currency, and the robot didn't start yet here. The DC motor didn't start. Where am I supposed to put it? There. So it says press enter and it will begin, and it said that it will run for 5 seconds straight. So let me put this here. It's not working. We don't see anything working. It's not going clockwise. It's not stopping. So, oh. Okay, it is going counterclockwise. And now it's stopped. And clockwise is not working. Okay. But counterclockwise is working, as you guys can see. Okay, awesome. So we're getting somewhere. Let me quit this quickly. So what do we know? We know that counterclockwise is working at this moment, and normal wise clockwise isn't working. So let us check. Direction, counterclockwise, stop, direction is 0. Direction is plus. Enable the motor. Output, motor enable. Motor pin, GPI high, low, direction. So what we see here in this source code is, yeah, motor pin 1, motor pin 2. But how did he know which is the right pin? I'm sorry, I don't understand this. I'm trying to figure this out, but it's a hard work. Motor enabled, go to low now. Define a dictionary to make the script more readable. Clockwise, counterclockwise, stop as stop. Yeah. Okay, what? Well, true. Clockwise. Yeah, this is a loop. But why isn't it rotating the counterclockwise rotation? Enabled. Maybe I have a very small error in my how you call it, my circuit board. I don't know. Let me get the screen again. Okay, set pin 1 and 2 for motors rotation. That was this part. And set pins for motor working condition as output pin. Set motor level for initial state. Set motor level in high level. Okay. Boring explanation, man. My own explanations are so much better. Have you seen my source code? Whenever I do something, I write so much information what actually happens. This makes no sense to me. This is C++. Motor enable high. Enable the L. So how did we enable it here in Python? Raw input, program is running. To numbering, set pins up. So confused why it would only turn into one direction. Why is it running? Why are you running? Why are you running? I have an error somewhere. Why? What's going on? Does it have something to do with this one? Maybe. I'm so confused, you guys. Now it stopped. But why isn't it running clockwise? Here the script is running, and whenever it goes to counterclockwise, it is running. But when it is the second ground connection and 2 ground connectors and 2 for 5V for motor drivers. I have 2 here and I have 2 on the ground. Yeah. And I have 2 voltage in here, like we saw on this here, this diagram. 27. Yeah, this one is connected to. Oh, I'm stupid. Remember how I was just saying that I look at things through an angle and I can't see it correctly? I have it in the wrong pin. It should be 1 pin down. So I accidentally had here number 18 in our screen. Can you see this? No, let's get the diagram. This pin here, I had it in this one on top here. So this green line was in the wrong pin. So now it does work correctly. So that was counterclockwise. And this one goes clockwise. Nice. So it is working. It was just my fault. I didn't see it right because I'm not looking from the top. If you're looking from the top, it will be a little bit more clear what's going on. Okay. What does this do? I don't know. It's a button. But let's stop this. Oh, quickly. Stop. Woo. Yes. Yes. Oh, we done 6 tutorials. No, we didn't do 6. We did, I think, 5. I'm very happy. I'm happy that it is working. I still don't know exactly what I'm supposed to do with this Raspberry Pi, but I am happy that I am able to use the Python language to communicate with this board over here. It didn't work. It didn't work as easy as I thought it would, but it does work, and that's a good thing. Awesome. So I'm gonna quit. I've had enough. I had a lot of fun, definitely. I'm happy that we did get this to work, that it was running clockwise and counterclockwise. And I'm starting to understand this Raspberry Pi a little bit better. I'm still not able to write my own scripts yet, but then again, you have to know what you want to write a script about, and I don't know even what I can do with this, so I have to think, and well, we'll figure it out on the long run, I guess. So, what am I supposed to do? Let me just start and clean this up a little bit. Because what time is it? It's 11 p.m. I think I've been live for 3.5 hours. I think that's enough. Don't you guys agree? Being live for 3.5 hours is a long time. So I think I'm gonna shut down this stuff. I'm gonna quit working with this Raspberry Pi, and maybe we can just talk about some stuff to end this live stream, and what I'm thinking about, maybe Bitcoin related stuff. Maybe you can ask me something or give me an idea what I can talk about. So in the meantime, I'm gonna shut down this stuff. And if you don't know what to talk about, I am going to Reddit. Already telling you this. For, let's say, for half an hour. I think that's fun. Am I gonna shut down the Raspberry Pi? Yeah, let's just shut it down completely. That's better. So shut down the Raspberry Pi. And shut it down. And while it is shutting down... Come on, I said shut down. No, you're not shutting down? Then you won't shut down. Don't care. Don't connect to it anymore. Maybe it works if I run here, shut down. Can't talk to daemon. Okay. So if I put reboot, am I allowed to reboot? No. Sudo shut down. I want it shut down. Oh, now it will shut down. Okay. Awesome. I can remove these pins. Yeah. The DC motor. And it was a lot of fun to work with this, to figure it out. Nothing. So let's get rid of all these pins and try and clean this up. So, let's keep it like this. It doesn't matter. Or not. No, I don't know. I'm gonna clean the Raspberry Pi up. So because usually I bought it with a case, although that case does not work perfectly. The reason why it's not working perfectly is because this thing here, this big connector, is bigger than the hole that we have here. It doesn't fit. So Stupid design. Too bad. I don't know, guys. Connect. So like that. We're supposed to connect them like that. And let me grab a. I need a screwdriver because I want to finish this off nicely. I shouldn't just keep. Oh, you see, it is disconnected, which means that it did shut down the Raspberry Pi now officially, even though the fan is still running. Where did I? Oh, come on! Work with me. Here we have a screwdriver. The reason is I need to remove these screws. Can I do it by hand? No. 1, 2, let go. Number 3, yeah. And now I should put this on top here. Oh, I'm forgetting a part. No. Sorry for being in the way. So this is how the Raspberry Pi should look like. What it should look like. How it should look like. So let me connect this and screw this up. I mean, let's tighten the screws. Let's not screw up this stuff. I hope you guys did enjoy this live stream. It was very, it wasn't very crowded, but then again, it is only crowded in my live streams whenever I have the word brute force or private key or watch only in my title. If it isn't in my title, then let's just call only my my most loyal viewers, my most loyal subscribers will be here, and otherwise we would only have people asking me for free money. So I'm glad that that didn't happen today. So this is what it would normally look like. A very small PC. Very small PC. And if you want to use this PC without a remote desktop, you can put an HDMI cable in here. See, that's the mini HDMI. Here we have the one side of the HDMI port, and there's the other side. You can connect it to a TV screen. And then you have your ordinary Raspberry Pi, or just a computer. But then you wouldn't be able to use the breadboard and all these extra options with Python. But yeah, like I tried to show you guys, I can't put this this big connector in here. It won't fit. It's too bad. It's just 1 or 2 millimeters, but it won't fit between between this hole, this big hole. Too bad. But yeah. Okay. I'm trying to clean my desk because it's very messy. I don't know if you guys, well, you can't see it, but a little bit now. A lot of mess. Yeah. The breadboard. Very nice. Very happy with what I bought. Oh, I have to clean this up, man. It's such a mess. Check this mess. All these small cables. Work with me. Messy stuff. So I hope you guys did enjoy it. I think I'm just gonna quit this live stream because I don't think that there are many people watching anymore. I didn't get any responses from you guys, so I think that you guys are away from keyboard. So hey, been a wonderful live stream. Hope you guys did enjoy it, and I will see you guys next time. So thank you for being here. Goodbye. Nobody cared. Nobody cared.